The night sky has always been a canvas for our deepest questions. What lies beyond the stars? Are we alone in this vast universe? Or could there be civilizations out there, watching the same skies, asking the same questions? Today, we're diving into one of the most fascinating mysteries of all, the search for alien civilizations. From mysterious signals that defy explanation to ancient artifacts that hint at contact with beings not of this world, we'll explore 36 of the most compelling enigmas that challenge everything we think we know about life beyond Earth. This isn't just a journey through space, it's a journey through possibility, one that could reshape how we see ourselves and our place in the cosmos. So, let's take a closer look at the evidence, the theories, and the unanswered questions that continue to captivate scientists, dreamers, and skeptics alike. The answers may be out there, and they might just be closer than we think. One of the most perplexing questions in the search for alien civilizations is the Fermi Paradox. Named after physicist Enrico Fermi, who famously asked, "Where is everyone?" during a casual conversation in the 1950s, this paradox highlights a striking contradiction. The universe is unimaginably large, with billions of galaxies, each containing billions of stars and planets. Statistically, the odds of life, and even intelligent civilizations existing elsewhere seem overwhelmingly high. Yet, despite decades of searching, we've found no definitive evidence of extraterrestrial life. So, what's going on? Why the silence? This paradox isn't just a thought experiment. It's a puzzle that has sparked countless theories. One of the most discussed is the Great Filter hypothesis. The idea is simple but unsettling. Somewhere along the evolutionary path from simple life to advanced civilization, there might be a nearly insurmountable barrier, a filter. This barrier could exist in our past, meaning life rarely evolves to our level of intelligence, or worse, it could lie ahead of us, suggesting that advanced civilizations inevitably destroy themselves before making contact with others. Could this explain why we haven't found anyone else out there? Then there's the possibility that advanced civilizations are intentionally avoiding detection. Imagine a universe where highly developed beings have mastered the art of staying hidden, perhaps to protect themselves or to avoid interfering with younger species like us. Or perhaps they've evolved beyond the need for physical exploration, existing in forms we can't yet comprehend or detect. It's a fascinating and slightly humbling idea that our current methods of searching might be too primitive to find them. But what if the answer is closer to home? Some scientists argue that the silence might be a result of our own technological and observational limitations. After all, we've only been seriously searching for extraterrestrial signals for a few decades, a mere blink in cosmic terms. The vastness of space, combined with the limited range of our instruments, means we might simply be missing the signs. Or perhaps alien civilizations communicate in ways we haven't even imagined yet, using technologies that are entirely beyond our understanding. The Fermi Paradox doesn't just challenge our assumptions about life in the universe, it forces us to confront the limits of our knowledge. Are we alone? Or are we just not looking in the right way? As we dive deeper into the mysteries of extraterrestrial enigmas, this paradox serves as a reminder that the answers we seek might be as much about us as they are about the stars. And with every new discovery, we inch closer to unraveling one of the greatest questions of all time. Are we truly alone? In the summer of 1977, a routine night at Ohio State University's Big Ear radio telescope turned into one of the most intriguing moments in the history of the search for extraterrestrial life. It was here that astronomer Jerry Amon, scanning the skies for unusual signals, came across something extraordinary, a burst of radio waves so powerful and unusual that he circled it on the printout in red ink and simply wrote, "Wow." Beside it, this brief 72-second signal, now famously known as the WOW signal, remains one of the most tantalizing mysteries in the hunt for alien civilizations. The signal originated from the direction of the constellation Sagittarius, near a star group called Chi Sagittarii. What made it so remarkable was its intensity and frequency. It clocked in at around 1,420 megahertz, a frequency close to the hydrogen line, a range scientists had long speculated might be used for interstellar communication. This wasn't just random noise, it was a narrowband signal, the kind that natural cosmic phenomena rarely produce. For a brief moment, it seemed like we might have stumbled upon a deliberate message from another world. But here's the twist: despite countless efforts to detect it again, the WOW signal has never been observed since. No follow-up, no repetition, no explanation. This has led to decades of debate. Could it have been a one-time transmission from an alien civilization, perhaps a beacon or a test signal, or was it something else entirely, a natural phenomenon we don't yet understand, or even a human-made signal bouncing off space debris? The possibilities are as intriguing as they are frustrating. Some scientists have proposed that the signal might have been caused by a comet, as two such objects were passing through that region of space at the time. Others argue that comets don't emit radio waves in the way the WOW signal did, making this explanation unlikely. Then there's the idea that it could have been a fleeting burst of energy from a distant star, or even a glitch in the telescope itself. But none of these theories fully explain why the signal was so strong, so precise, and so unlike anything else we've ever detected. What makes the WOW signal so compelling isn't just the mystery of its origin, it's the way it embodies the challenges and hopes of the search for extraterrestrial life. It's a reminder that the universe is full of surprises, and sometimes the most profound discoveries come in the blink of an eye. Whether it was a message from an alien civilization or a cosmic fluke, the WOW signal continues to inspire scientists and dreamers alike, urging us to keep looking, keep listening, and keep wondering what else might be out there, waiting to be found. While the WOW signal and the Fermi Paradox challenge us with questions and mysteries, the Drake equation offers a different approach, a way to quantify the possibilities. Developed by astrophysicist Frank Drake in 1961, this equation isn't about finding answers so much as framing the questions. It's a tool that helps us think systematically about the likelihood of intelligent life beyond Earth, breaking down the vast unknowns into manageable pieces. At its core, the Drake equation is a series of variables multiplied together, each representing a critical factor in the search for alien civilizations. The first variable is the rate at which stars form in our galaxy. With billions of stars in the Milky Way alone, this number sets the stage for the sheer scale of the cosmic playground. Next comes the fraction of those stars that host planetary systems. Thanks to modern telescopes like Kepler and TESS, we now know that planets are incredibly common. Almost every star seems to have at least one. From there, the equation narrows its focus to the number of planets within each system that could support life. These are the so-called Goldilocks planets, where conditions are just right, not too hot, not too cold for liquid water to exist. But even here, life isn't guaranteed. The next variable considers the fraction of these habitable planets where life actually emerges. This is where things get speculative. While we know life arose on Earth, we still don't understand how likely it is to happen elsewhere. the equation then shifts to the development of intelligent life. Out of all the planets where life begins, how many give rise to civilizations capable of communication? This is a tricky one, as intelligence might be common, or it might be an incredibly rare fluke of evolution. Finally, the equation considers how long such civilizations might last. Even if intelligent life is out there, would it survive long enough to send signals across the stars, or would it self-destruct, as some fear humanity might? When you multiply all these variables together, the result is an estimate of the number of active, communicative civilizations in our galaxy. The beauty of the Drake equation lies in its flexibility. Depending on how optimistic or pessimistic you are about each factor, the number can range from just a handful to millions. This uncertainty isn't a flaw, it's a feature. The equation doesn't give us answers, it gives us a framework for thinking about the unknowns. Over the decades, science has refined some of these variables. We now know planets are abundant, and we've identified thousands of potentially habitable worlds, but other factors, like the likelihood of intelligent life or the longevity of civilizations, remain shrouded in mystery. Some argue that the equation is too speculative to be useful, while others see it as a vital tool for guiding our search. Either way, it's a reminder of how much we still have to learn and how much potential there is for discovery. The Drake equation is more than just math. It's a conversation starter, a way to explore the big questions about life, intelligence, and our place in the universe. It challenges us to consider not just whether we're alone, but what it would mean if we weren't. And as our technology improves and our understanding deepens, this equation will continue to evolve, offering new insights into one of humanity's oldest and most profound questions. Are we truly the only ones out here? The search for alien civilizations isn't just about wondering if they exist, it's also about figuring out where they might be. With over 5,000 exoplanets discovered so far, the universe is showing us that planets are everywhere. But not all planets are created equal. The key to finding life beyond Earth lies in identifying those rare worlds that fall within the so-called Goldilocks zone, not too hot, not too cold, but just right for liquid water and potentially life as we know it. Take Proxima Centauri b, for example. Located just over 4 light-years away, this exoplanet orbits the closest star to our solar system. It's a rocky world, similar in size to Earth, and sits within its star's habitable zone. But Proxima Centauri b isn't without its challenges. Its parent star is a red dwarf, known for intense stellar flares that could bombard the planet with radiation. Could life survive in such a harsh environment? Some scientists think it's possible, especially if the planet has a protective atmosphere or magnetic field. Proxima Centauri b is a tantalizing reminder that habitable worlds might be closer than we think, but they might also be very different from our own. Then there's the TRAPPIST-1 system, a star about 39 light-years away that's home to not one but 7 Earth-sized planets. 3 of these planets, TRAPPIST-1e, F, and G, are nestled firmly within the habitable zone. What makes this system so exciting is the possibility of multiple worlds, each with its own unique conditions, all orbiting the same star. Imagine the potential for life to evolve in such a diverse environment. While we don't yet know if these planets have atmospheres or water, their discovery has opened up a whole new realm of possibilities for what a habitable system might look like. But finding a Goldilocks planet is just the beginning. Scientists also look for biosignatures, chemical clues that could indicate the presence of life. These might include oxygen, methane, or even the faint traces of industrial pollution in a planet's atmosphere. Detecting these signs requires incredibly advanced technology, like the James Webb Space Telescope, which is now peering into the atmospheres of distant worlds. Every new discovery brings us closer to answering the ultimate question: could these planets be home to alien civilizations? Of course, the search for habitable worlds isn't just about finding Earth-like planets. Some scientists are exploring the possibility of life in places we once thought were inhospitable. Take Europa, one of Jupiter's moons, with its vast subsurface ocean. Or Enceladus, a moon of Saturn, where geysers of water erupt from beneath its icy surface. These worlds remind us that life might thrive in environments we've barely begun to understand. The hunt for habitable exoplanets is more than a scientific endeavor. It's a journey of imagination and discovery. Every new world we find expands our understanding of what's possible in the universe. And as we uncover more of these distant planets, we're not just searching for aliens, we're learning more about our own place in the cosmos. The question isn't just where could aliens live, it's also how they might live and what that could teach us about the nature of life itself. For over 6 decades, the search for extraterrestrial intelligence, or SETI, has been humanity's ear to the cosmos, listening intently for whispers from civilizations beyond our own. This ambitious project represents one of the most systematic efforts to answer a question that has haunted us for centuries. Are we alone? Using powerful radio telescopes and cutting-edge technology, SETI scientists have been scanning the skies, searching for patterns or signals that defy natural explanations. But what does it take to sift through the endless static of the universe? And what would it mean if we actually heard something? At the heart of SETI work are radio telescopes, massive instruments designed to detect radio waves from distant stars and galaxies. These telescopes act like cosmic ears, picking up signals that travel across light years of space. But here's the challenge: the universe is far from silent. Stars, black holes, and even human-made satellites all produce radio waves, creating a cacophony of cosmic noise. The trick is to find the needle in the haystack, a signal that stands out as artificial, something that couldn't have been produced by natural processes. One of the key tools in this search is the Allen Telescope Array, a network of small radio dishes in Northern California. Unlike traditional telescopes, which focus on a single point in the sky, this array can scan multiple regions simultaneously, dramatically increasing the chances of detecting something unusual. SETI researchers also use sophisticated software to analyze the data, looking for patterns that might indicate a deliberate message. But even with these advanced tools, the task is daunting. The universe is vast, and the signals we're searching for could be incredibly faint or fleeting. Despite these challenges, SETI has had its share of tantalizing moments. Take, for example, the famous WOW signal we discussed earlier. While it remains unexplained, it's a reminder of the potential for discovery. More recently, in 2020, astronomers detected a radio signal coming from Proxima Centauri, the closest star system to our own. The signal, dubbed BLC-1, initially seemed promising. It was narrowband, the kind of signal SETI looks for. But after months of analysis, it was traced back to human-made interference. This highlights another hurdle, distinguishing between signals from distant stars and the ever-increasing noise from our own technology. But what if SETI did find a confirmed signal? What would that mean for humanity? For starters, it would be one of the most profound discoveries in history, reshaping our understanding of life and our place in the universe. It could spark a new era of scientific collaboration, as researchers from around the world work to decode the message and determine its origin, and it would force us to confront questions we've never had to answer before. How should we respond? What would we say? And perhaps most importantly, how would such a discovery change the way we see ourselves? Of course, not everyone agrees on the likelihood of SETI success. Some argue that the odds of detecting a signal are vanishingly small, given the vastness of space and the limitations of our technology. Others suggest that advanced civilizations might communicate in ways we can't yet detect, using technologies beyond our current understanding. But even skeptics acknowledge the importance of the effort. By searching for alien signals, we're not just looking for life. We're pushing the boundaries of science and technology, learning more about the universe in the process. SETI mission is more than a scientific endeavor. It's a testament to human curiosity and ingenuity. It's a reminder that, even in the face of overwhelming odds, we're driven to explore, to question, and to connect. Whether or not we ever find a signal, the search itself is a powerful statement about who we are and what we value. And as our tools and techniques continue to improve, the possibility of discovery grows ever closer. The universe is vast, but so is our determination. And somewhere out there, among the stars, the answer to one of our oldest questions might be waiting to be found. In the vast tapestry of the cosmos, few stars have sparked as much intrigue and debate as Tabby's star, officially known as KIC 8462852. Located about 1,400 light-years away in the constellation Cygnus, this star has become a focal point in the search for extraterrestrial intelligence, not because of what it's doing, but because of what it's not doing. Unlike most stars, which shine with predictable consistency, Tabby's star flickers and dims in ways that defy easy explanation. Its irregular light patterns have puzzled astronomers since their discovery in 2015, and the mystery has only deepened with time. The first clue to Tabby's star's odd behavior came from data collected by NASA's Kepler Space Telescope. Kepler, designed to detect exoplanets by measuring the tiny dips in a star's brightness when a planet passes in front of it, recorded something far more unusual. Instead of the regular, periodic dimming caused by orbiting planets, Tabby's star showed erratic and dramatic drops in brightness, sometimes by as much as 22%. These dips weren't consistent in size, shape, or timing, leaving scientists scratching their heads. What could possibly block that much light, and why would it happen so unpredictably? One of the earliest and most plausible explanations involved swarms of comets. Imagine a massive cloud of icy debris orbiting the star, occasionally passing in front of it and blocking its light. This theory gained traction because it didn't require invoking alien technology, but there was a problem. The sheer number of comets needed to create such a dramatic effect would be unprecedented. Comet swarms on this scale have never been observed elsewhere in the universe, making this explanation intriguing but far from conclusive. Then there's the more exotic and admittedly more exciting possibility: alien megastructures. Some scientists have suggested that the irregular dimming could be caused by a massive construction project, like a Dyson sphere or a swarm of solar panels, built by an advanced civilization to harness the star's energy. While this idea has captured the public's imagination, it's important to note that it's considered a long shot by most astronomers. The scientific community generally prefers natural explanations over speculative ones, but the sheer strangeness of Tabby's star keeps the door open to all possibilities. Another theory points to the star itself. Perhaps Tabby's star is undergoing internal changes, such as fluctuations in its magnetic field or unusual stellar activity that cause its brightness to vary. Or maybe it's surrounded by a thick, uneven ring of dust and debris, similar to the protoplanetary disks seen around young stars. These natural explanations are more likely, but they still don't fully account for the star's bizarre behavior. What makes Tabby's star so fascinating isn't just the mystery of its dimming, it's what the mystery represents. This star challenges our assumptions about how stars behave and forces us to consider possibilities we might otherwise dismiss. It's a reminder that the universe is full of surprises, and sometimes the most ordinary-looking objects can hold the most extraordinary secrets. As scientists continue to study Tabby's star, using telescopes like Hubble and the James Webb Space Telescope, they're not just looking for answers, they're also refining the tools and techniques we use to explore the cosmos. Whether the solution turns out to be swarms of comets, alien megastructures, or something entirely new, Tabby's star has already left its mark on astronomy. It's a testament to the power of curiosity and the endless potential for discovery in the universe. And who knows, the next big breakthrough in our search for alien civilizations might just come from a star that refuses to behave like any other. In 1974, humanity took a bold step into the unknown. From the iconic Arecibo Observatory in Puerto Rico, scientists beamed a radio message into the depths of space, aimed at a star cluster known as Messier 13, 25,000 light-years away. This transmission, known as the Arecibo Message, wasn't just a scientific experiment, it was a cosmic handshake, our first deliberate attempt to say, "We're here," to any civilizations that might be listening. But what exactly did we say, and why does this message still captivate us nearly 50 years later? The Arecibo Message was a carefully crafted binary code, a series of ones and zeros that, when decoded, forms a visual representation. At its core, the message was designed to convey basic information about humanity and our planet. It included a depiction of the numbers 1 through 10, the atomic numbers of key elements like hydrogen and carbon, the structure of DNA, a stick figure of a human, and even a schematic of the Arecibo telescope itself. In just 1,679 bits of data, the message aimed to paint a picture of who we are and where we come from. It was a snapshot of Earth's scientific and biological essence, sent across the void in the hope that someone, or something, might one day understand it. But let's be clear, the Arecibo Message wasn't just about making contact. Its primary purpose was to demonstrate the power of human technology and our ability to communicate across vast distances. At the time, the Arecibo Observatory was the largest and most powerful radio telescope in the world, and this message was a showcase of its capabilities. Even if no one ever receives it, the act of sending it was a milestone, a declaration that humanity was ready to engage with the cosmos in a meaningful way. Of course, the odds of a reply are vanishingly small. Messier 13 is so distant that even if an advanced civilization intercepted the message and responded immediately, it would take 50,000 years for their reply to reach us. And that's assuming they're even listening, or that they understand the message in the first place. Interstellar communication is fraught with challenges. How do you create a message that's universally understandable? How do you account for differences in language, culture, or even biology? These are questions the Arecibo Message didn't fully answer, but it sparked a conversation that continues to this day. If we were to send a message today, what would it look like? Would we include more details about our culture, our history, or our hopes for the future? Or would we focus on scientific data, believing that math and physics are the universal languages of the cosmos? Some scientists argue that any message should be simple and visual, like the Arecibo Message, while others suggest we might need to think outside the box entirely, perhaps using sound, light, or even art to convey our ideas. The Arecibo Message may have been humanity's first cosmic greeting, but it's unlikely to be our last. As our understanding of the universe grows, so too does our ability to communicate across it. Whether or not we ever receive a reply, the act of reaching out is a powerful statement about who we are, a species driven by curiosity, connection, and the hope that we're not alone. And in that sense, the Arecibo Message isn't just a message to the stars, it's a message to ourselves, a reminder of our place in the universe and the limitless possibilities that lie ahead. What if, right now, we're being observed not by scientists in a lab, but by beings from another world? This is the core idea behind the zoo hypothesis, a concept that turns the search for alien civilizations on its head. Instead of wondering why we haven't found them, this theory asks, what if they've already found us? What if advanced extraterrestrial civilizations are watching us from a distance, deliberately avoiding contact, much like humans observe animals in a zoo? It's a thought that's both fascinating and slightly unsettling, raising questions about our place in the universe and the ethics of observation on a cosmic scale. The zoo hypothesis was first proposed in the 1970s by astronomer John Ball, who suggested that advanced alien societies might choose to leave us untouched, allowing us to develop naturally without interference. This could be out of respect for our autonomy, or perhaps because they see us as a kind of living experiment, a way to study a young civilization in its natural state. Imagine Earth as a cosmic wildlife preserve, with humanity as the main exhibit. It's a humbling idea, one that challenges our assumptions about being the most advanced beings in the universe. But why would aliens choose to remain hidden? One possibility is that they're adhering to a kind of galactic ethical code, one that prioritizes non-interference. Just as modern conservationists strive to protect endangered species by minimizing human impact, advanced civilizations might see value in letting us evolve without outside influence. After all, contact with a more advanced species could have unpredictable consequences, potentially disrupting our development or even leading to our extinction. By staying in the shadows, these hypothetical aliens could be ensuring our survival and preserving the natural diversity of the cosmos. Another angle to consider is the idea of a galactic quarantine. What if humanity is being kept isolated, not out of benevolence, but because we're considered dangerous or unstable? Think about it. Our history is marked by conflict, environmental destruction, and technological misuse. To a highly advanced civilization, we might seem like a risky species to engage with. By keeping us at arm's length, they could be protecting themselves and the rest of the galaxy from the potential fallout of our actions. It's a sobering thought, but one that forces us to reflect on our own behavior and its broader implications. Of course, the zoo hypothesis isn't without its critics. Some argue that it's too speculative, relying on assumptions about alien motivations that we can't possibly verify. Others point out that if advanced civilizations are out there, they might not all agree on the same ethical principles. What one species sees as non-interference, another might view as neglect, and then there's the question of scale. With billions of stars and planets in the galaxy, how likely is it that every advanced civilization would choose to leave us alone? The universe is vast and varied, and the idea of a unified galactic protocol seems almost too neat. Still, the zoo hypothesis serves a valuable purpose. It challenges us to think differently about the search for alien life, shifting the focus from where they are to why they might not want to be found. It also invites us to consider our own role in the cosmos. Are we the observers or the observed? And if we are being watched, what might those watchers think of us? These questions don't just speculate about the nature of alien civilizations, they also prompt us to reflect on our own humanity, our choices, and our future. Whether or not the zoo hypothesis is true, it offers a compelling framework for thinking about our place in the universe. It reminds us that the search for extraterrestrial intelligence isn't just about finding life, it's about understanding ourselves. And as we continue to explore the cosmos, we might just discover that the answers we seek are closer than we think, hidden not in the stars, but in the mirror. What if the building blocks of life are scattered across the cosmos, just waiting to be discovered? This is the central question driving astrobiology, a field that bridges biology, chemistry, and astronomy to explore the origins and potential for life beyond Earth. Astrobiologists aren't just searching for alien civilizations, they're investigating the fundamental conditions that make life possible, from the chemistry of molecules to the environments that nurture them. By studying life in the most extreme corners of our own planet and analyzing the atmospheres of distant worlds, they're piecing together a universal blueprint for life, one that could change everything we know about the universe. At its core, astrobiology asks, what does it take for life to emerge? To answer this, scientists start with what we know, life on Earth. Our planet teems with organisms that thrive in environments once thought inhospitable, from scorching hydrothermal vents to the frozen deserts of Antarctica. These extremophiles, as they are called, are proof that life can adapt to conditions far harsher than we once imagined. If life can exist here, in such extreme settings, why not on other planets or moons? This question has led astrobiologists to explore places like Mars, Europa, and Enceladus, where conditions might be similar to Earth's most hostile environments. But it's not just about finding water or the right temperature. Life requires a complex interplay of chemical ingredients: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. These are the elements that form the backbone of life as we know it. Astrobiologists study how these elements come together to create organic molecules, the building blocks of life. One of the most exciting discoveries in recent years has been the detection of complex organic molecules in space. From the icy plumes of Enceladus to the ancient rocks of Mars, these findings suggest that the raw materials for life might be more common than we ever realized. Take, for example, the discovery of amino acids in meteorites. These molecules, essential for building proteins, have been found in space rocks that have fallen to Earth. This raises a tantalizing possibility. Could life have started elsewhere and traveled here, seeding our planet with its first organisms? This idea, known as Panspermia, is still speculative, but it highlights the interconnectedness of the cosmos and the potential for life to spread across the stars. Of course, not all life needs to look like life on Earth. Astrobiologists are also exploring the possibility of alternative biochemistries, life forms that use different elements or chemical processes. For instance, could a planet with oceans of liquid methane host life that relies on silicon instead of carbon? Or could organisms exist in environments with no oxygen at all, using entirely different metabolic pathways? These questions push the boundaries of what we consider life and force us to think creatively about the diversity of the universe. To answer these questions, astrobiologists rely on cutting-edge technology. Telescopes like the James Webb Space Telescope are analyzing the atmospheres of distant exoplanets, searching for chemical signatures that might indicate life. Meanwhile, rovers like NASA Perseverance are drilling into Martian rocks, looking for fossilized evidence of ancient microbes. These missions are not just about finding life, they're about understanding the conditions that make life possible and how those conditions might exist elsewhere. Astrobiology is more than a scientific discipline, it's a mindset, a way of thinking about our place in the universe. It challenges us to consider that life might not be a rare accident, but a natural outcome of cosmic processes. By studying the origins and potential for life, we're not just searching for aliens, we're uncovering the universal principles that govern existence itself. And as we continue to explore, we might just discover that the cosmos is far more alive than we ever imagined. Among the countless mysteries of the cosmos, few are as baffling or as fleeting as fast radio bursts, or FRB. These incredibly powerful bursts of radio waves last just a few milliseconds, but in that blink of an eye, they release as much energy as the sun does in decades. First discovered in 2007, FRBs have since become one of the most intriguing puzzles in modern astronomy. Where do they come from? What could possibly produce such a sudden, intense burst of energy? And, perhaps most tantalizing of all, could they be signals from an alien civilization? Fast radio bursts are so brief and unpredictable that catching them in action is like trying to photograph a lightning strike in a thunderstorm. Most of the time, they're detected after the fact, as faint echoes in the data collected by radio telescopes. But despite their elusiveness, astronomers have managed to identify over 100 of these bursts since their discovery, and some even repeat, sending out multiple bursts over time. This repetition has been a game changer, giving scientists a chance to study these mysterious signals in greater detail. So, what's causing them? The leading theories point to natural cosmic phenomena. One popular idea involves magnetars, highly magnetic neutron stars that occasionally release enormous bursts of energy. When a magnetar's intense magnetic field twists and snaps, it could produce a shock wave powerful enough to generate an FRB. Another possibility is the collision of dense objects like neutron stars or black holes, events so cataclysmic that they send ripples of energy across the universe. These explanations fit well with what we know about astrophysics, but they don't fully account for all the quirks observed in FRBs, like their repeating patterns or the vast distances some of them seem to travel. This uncertainty has led some to wonder, could FRBs be artificial? Could they be signals from advanced alien civilizations, perhaps even attempts at communication? It's a provocative idea and one that can't be entirely ruled out, at least not yet. If an alien society wanted to broadcast its presence across the galaxy, a powerful, short-lived burst of radio waves might be an effective way to do it. The energy required to produce an FRB would be staggering, but for a civilization far more advanced than our own, it might not be out of reach. Of course, the scientific community remains cautious. While the idea of alien messages is undeniably exciting, most researchers emphasize that extraordinary claims require extraordinary evidence. So far, there's no definitive proof linking FRBs to extraterrestrial technology. But that hasn't stopped scientists from exploring the possibility. In 2017, for example, a team of researchers suggested that FRBs could be used as a kind of cosmic GPS, helping aliens navigate the vast distances of space. It's a fascinating thought, even if it remains speculative. What makes FRBs so compelling isn't just the mystery of their origin, it's what they reveal about the universe. These bursts travel billions of light years to reach us, passing through galaxies, gas clouds, and magnetic fields along the way. By studying how FRBs are distorted during their journey, astronomers can map the otherwise invisible structures of the cosmos, using these bursts as cosmic flashlights. In this way, FRBs aren't just puzzles to solve, they're tools for discovery, helping us explore the universe in ways we never thought possible. Whether FRBs are natural phenomena or something more, they remind us of how much we still have to learn about the cosmos. Every burst raises new questions, challenging our assumptions and pushing the boundaries of our knowledge. As telescopes grow more powerful and our methods of detection improve, we may one day uncover the true nature of these enigmatic signals. Until then, FRBs will continue to captivate our imagination, offering a glimpse into the vast, mysterious, and endlessly surprising universe we call home. The search for alien life often conjures images of little green beings or mysterious spacecraft. But what if the evidence we're looking for isn't biological at all? Enter Technosignatures, the fingerprints of advanced technology left behind by extraterrestrial civilizations. Unlike traditional biosignatures, which focus on the chemical traces of life, Technosignatures hunt for the markers of intelligence and industry. These could range from massive structures harnessing the energy of stars to the faint traces of pollution in a distant planet's atmosphere. The idea is as simple as it is profound. If advanced civilizations exist, they might leave behind clues in the form of their technology, and we might just be able to detect them. One of the most iconic examples of a technosignature is the Dyson sphere, a concept first proposed by physicist Freeman Dyson in the 1960s. Imagine a civilization so advanced that it builds a colossal structure around its star, capturing its energy to power its society. From a distance, such a megastructure would block a significant portion of the star's light, creating a distinct infrared signature as the absorbed energy is re-emitted as heat. Astronomers have already begun scanning the skies for stars with unusual light patterns, searching for the telltale signs of a Dyson sphere or similar constructs. While no definitive discoveries have been made yet, the search continues, driven by the tantalizing possibility that we might one day spot the handiwork of an alien civilization. But technosignatures don't have to be as grandiose as a Dyson sphere. They could also be far subtler, like the chemical byproducts of industrial activity. On Earth, human industry has left its mark on our atmosphere in the form of pollutants like chlorofluorocarbons or CFC. These chemicals, which don't occur naturally, could serve as a kind of cosmic red flag if detected on another planet. Telescopes like the James Webb Space Telescope are now capable of analyzing the atmospheres of distant exoplanets, searching for anomalies that might indicate the presence of technology. A whiff of CFCs or other artificial compounds could be the first hint that we're not alone. Then there's the possibility of detecting artificial light or heat signatures. Imagine a planet where cities glow brightly against the dark backdrop of space, or where the energy consumption of a civilization creates a noticeable thermal footprint. These kinds of technosignatures would be incredibly challenging to detect with current technology, but they're not beyond the realm of possibility. As our instruments grow more sophisticated, the chances of spotting such subtle clues increase, opening up new avenues in the search for alien life. Of course, the search for technosignatures isn't without its challenges. Natural phenomena can sometimes mimic the signals we're looking for, leading to false positives. For example, a star with a dusty debris disk might produce an infrared signature similar to a Dyson sphere. Similarly, unusual atmospheric chemistry on a distant planet could have natural explanations unrelated to industrial activity. Distinguishing between these possibilities requires careful analysis and a healthy dose of skepticism, but even the process of ruling out false positives teaches us more about the universe, refining our methods and sharpening our ability to detect true technosignatures. What makes the search for technosignatures so exciting is its potential to revolutionize our understanding of the cosmos. If we were to detect evidence of alien technology, it wouldn't just confirm the existence of extraterrestrial life, it would reveal something about their capabilities, their priorities, and perhaps even their history. Are they builders, harnessing the energy of stars to power vast civilizations? Are they explorers, leaving behind artifacts as they traverse the galaxy, or are they something entirely beyond our imagination? The search for technosignatures is more than a scientific endeavor. It's a journey into the unknown, a quest to uncover the traces of civilizations that might be out there, waiting to be discovered. And as we continue to scan the skies, we're not just looking for answers, we're redefining what it means to search for life in the universe. Whether we find a Dyson sphere, a polluted atmosphere, or something entirely unexpected, the pursuit of technosignatures reminds us that the cosmos is full of possibilities, and the next great discovery might be just around the corner. For decades, the skies have been filled with stories of strange lights, hovering crafts, and objects that defy explanation. These unidentified flying objects, or UFOs, have captured the public's imagination, becoming a symbol of the possibility that we're not alone in the universe. But what are we really looking at when we see a UFO? Are they evidence of alien visits, or is there a more grounded explanation? The truth is, the story of UFOs is as much about us as it is about what might be out there. The modern fascination with UFOs began in the 1940s with the infamous Roswell incident. In 1947, a rancher in New Mexico discovered strange debris scattered across his property, sparking rumors of a crashed alien spacecraft. While the U.S. military later claimed it was a weather balloon, the incident ignited a wave of UFO sightings and conspiracy theories that continues to this day. Since then, countless reports have poured in from around the world, describing everything from glowing orbs to massive triangular crafts. But despite the sheer volume of sightings, the vast majority of these cases have been explained as misidentified aircraft, weather phenomena, or even hoaxes. Yet, there's a small percentage, about 5%, that remain unexplained. These are the cases that keep scientists and enthusiasts alike intrigued. Take, for example, the Nimitz encounters in 2004, when U.S. Navy pilots reported seeing a tic-tac-shaped object moving in ways that defied the laws of physics. The incident was later confirmed by the Pentagon, adding a layer of credibility to the mystery. Could these unexplained sightings be glimpses of alien technology, or are they simply phenomena we don't yet understand? The scientific community has traditionally been skeptical of UFOs, often dismissing them as pseudoscience, but in recent years, there's been a notable shift in attitude. Governments, including the United States, have declassified military footage of UFO encounters and even established task forces to investigate these phenomena. This newfound openness has sparked a broader conversation about the need for serious scientific inquiry into UFOs. After all, if even a fraction of these sightings represent advanced technology, whether human-made or extraterrestrial, it could have profound implications for our understanding of physics, engineering, and even our place in the cosmos. One of the biggest challenges in studying UFOs is the stigma surrounding the topic. For years, reporting a UFO sighting was met with ridicule, discouraging credible witnesses from coming forward. But as attitudes change, so does the quality of the data. Pilots, military personnel, and even astronauts are now more willing to share their experiences, providing researchers with first-hand accounts that are harder to dismiss. This shift has led to a more nuanced understanding of UFOs, one that acknowledges the possibility of both natural and extraordinary explanations. So, what could these unexplained UFOs be? Some scientists speculate they might be advanced military aircraft, developed in secrecy and mistaken for something otherworldly. Others suggest they could be natural phenomena that we simply don't have the tools or knowledge to identify yet. And then there's the tantalizing possibility that they are, in fact, evidence of alien technology, crafts visiting Earth from distant star systems. While this idea remains speculative, it's a reminder that the universe is full of mysteries, and our understanding of it is still evolving. The study of UFOs isn't just about answering the question of whether aliens have visited Earth. It's about embracing the unknown and challenging our assumptions. By examining these phenomena with an open mind and rigorous scientific methods, we're not just searching for answers, we're expanding the boundaries of what we consider possible. Whether UFOs turn out to be alien visitors, secret technology, or something entirely new, their story is a testament to our curiosity and our relentless drive to explore the unexplained. And in that sense, the search for answers is just as important as the answers themselves. While the search for intelligent life often takes center stage, the first extraterrestrial life we discover might not be little green beings, it could be something much smaller. Microbial life, though less dramatic, could be the key to answering one of humanity's most profound questions. Are we alone? Across our solar system, there are tantalizing hints that life might exist in places we once thought barren. From the frozen oceans of Europa to the ancient riverbeds of Mars, these worlds are offering us a glimpse into the potential for life beyond Earth, and the missions designed to uncover it. Mars, our neighboring planet, has long been a focal point in the search for microbial life. Billions of years ago, it was a very different world, with flowing rivers, vast lakes, and possibly even an ocean. Today, the surface is dry and desolate, but evidence of this watery past remains. NASA Perseverance rover is currently exploring Jezero Crater, a site believed to have once been a lake. The rover is collecting rock samples that could contain fossilized remnants of ancient microbial life, preserved in the sediments of a long-vanished shoreline. If life ever existed on Mars, these samples might hold the proof we've been searching for. But Mars isn't the only place where microbial life might thrive. Europa, one of Jupiter's moons, is another prime candidate. Beneath its icy surface lies a vast ocean, kept liquid by the gravitational forces of Jupiter tugging at its core. This subsurface ocean could be teeming with life, protected from the harsh radiation of space by a thick layer of ice. NASA's upcoming Europa Clipper mission aims to study this moon in unprecedented detail, searching for signs of plumes that might erupt from the ocean below. If these plumes contain organic molecules or even microbial life, they could provide the first direct evidence of life beyond Earth. Then there's Enceladus, a small moon of Saturn that has surprised scientists with its geysers of water ice. These plumes, first discovered by the Cassini spacecraft, originate from a subsurface ocean that could be rich in the chemical ingredients necessary for life. Enceladus's geysers spew water, salts, and even organic molecules into space, offering a tantalizing opportunity to study its ocean without having to drill through miles of ice. future missions could fly through these plumes, analyzing their contents for signs of microbial life. The idea that we might find life on such a small, distant moon is a testament to how diverse and unexpected the universe can be. One of the most exciting aspects of searching for microbial life is the variety of environments it might inhabit. On Earth, we've found microbes thriving in the most extreme conditions, from the scalding hot springs of Yellowstone to the acidic waters of volcanic lakes. These extremophiles have expanded our understanding of where life can exist, and they've given us hope that life might be more widespread in the universe than we ever imagined. If microbes can survive in such harsh environments here, why not on Mars, Europa, or Enceladus? The search for microbial life isn't just about finding tiny organisms, it's about understanding the origins and limits of life itself. If we discover microbes on another world, it could mean that life is a common occurrence in the universe, arising wherever the right conditions exist. It could also provide clues about how life began on Earth, offering a glimpse into our own distant past. And while microbial life might not be as flashy as an alien civilization, its discovery would still be a monumental moment, reshaping our understanding of biology, chemistry, and our place in the cosmos. As missions to Mars, Europa, and Enceladus continue to push the boundaries of exploration, we're inching closer to answering one of humanity's oldest questions. The search for microbial life is a reminder that even the smallest discoveries can have the biggest impact. Whether it's a fossilized microbe on Mars or a living organism in the icy depths of Europa, the evidence we're seeking might be closer than we think, and it could change everything we know about life in the universe. As we venture further into the cosmos, one of our most powerful tools in the search for alien life isn't a telescope or a rover, it's artificial intelligence. AI is transforming the way we explore the universe, sifting through mountains of data with speed and precision that would be impossible for humans alone. From decoding faint radio signals to analyzing the atmospheres of distant exoplanets, AI is opening new doors in our quest to answer the ultimate question: are we alone? But how exactly is this technology reshaping the search, and could it be the key to unlocking one of the universe's greatest mysteries? The challenge of searching for extraterrestrial life lies in the sheer scale of the data. Modern telescopes and space missions generate staggering amounts of information, far more than any team of scientists could hope to process manually. This is where AI steps in. Machine learning algorithms, trained to recognize patterns and anomalies, are being deployed to analyze everything from radio waves to light spectra. For example, SETI Breakthrough Listen project uses AI to scan millions of radio frequencies, searching for signals that stand out from the cosmic background noise. These algorithms can detect subtle patterns that might escape human notice, potentially uncovering the faint whispers of an alien civilization. But AI's role doesn't stop at signal detection. It's also revolutionizing how we study exoplanets. Telescopes like the James Webb Space Telescope collect vast amounts of data on the atmospheres of distant worlds, looking for chemical signatures that might indicate life. AI can quickly analyze this data, identifying compounds like oxygen, methane, or even industrial pollutants that could hint at the presence of intelligent beings. By automating this process, AI allows researchers to focus on interpreting the results rather than drowning in the sheer volume of information. It's a partnership between human curiosity and machine efficiency, pushing the boundaries of what we can discover. One of the most exciting applications of AI is its ability to think outside the box. Unlike traditional algorithms, which follow strict rules, machine learning can adapt and learn from the data it processes. This flexibility makes it uniquely suited to uncovering the unexpected. For instance, AI could identify unusual light patterns around a star, suggesting the presence of a megastructure like a Dyson sphere. Or it might detect subtle changes in a planet's atmosphere that point to industrial activity. These are the kinds of discoveries that could rewrite our understanding of the universe, and AI is uniquely positioned to make them. Of course, relying on AI comes with its own set of challenges. One of the biggest is the risk of false positives. The universe is full of natural phenomena that can mimic the signals we're searching for, from pulsars to cosmic dust clouds. AI might flag these as potential signs of life, leading to excitement and disappointment when further analysis reveals a natural explanation. To address this, scientists are working to refine AI models, teaching them to distinguish between genuine anomalies and cosmic noise. It's a delicate balance, but one that's essential for ensuring the credibility of any discoveries. Another challenge is ensuring that AI remains a tool rather than a replacement for human insight. While machines can process data at incredible speeds, they lack the intuition and creativity that humans bring to the table. The best approach is a collaborative one, where AI handles the heavy lifting of data analysis, and humans interpret the results, asking the big questions and exploring the implications. Together, this partnership could lead to breakthroughs that neither could achieve alone. The potential of AI in the search for alien life is immense, but it also raises profound questions. What happens if AI does detect a signal from an alien civilization? How would we verify it, and how would we respond? These are questions that scientists, ethicists, and policymakers are already grappling with. The role of AI isn't just about finding answers, it's about preparing us for the moment when those answers arrive. As we continue to push the boundaries of exploration, AI stands as a testament to human ingenuity. It's a tool that amplifies our ability to explore, to question, and to dream. Whether it's uncovering the faintest whispers of a distant civilization or revealing new worlds hidden in the data, AI is helping us see the universe in ways we never could before. And in doing so, it's bringing us closer than ever to answering one of humanity's oldest and most profound questions. Are we truly alone? Imagine this, the seeds of life, drifting through the vast emptiness of space, hitching a ride on a comet or meteorite, and eventually finding a new home on a young, fertile planet like Earth. This is the essence of Panspermia, a theory that suggests life might not have originated on our planet at all, but could have arrived here from somewhere else in the cosmos. It's a mind-bending idea that challenges our understanding of life's beginnings and raises a fascinating question. Could we all be cosmic travelers, descended from organisms that journeyed across the stars? The concept of panspermia isn't new. In fact, it dates back to ancient Greece, where philosophers like Anaxagoras speculated that life could exist throughout the universe. But it wasn't until the 19th century that the idea gained scientific traction, thanks to researchers like Svante Arrhenius, who proposed that microscopic life could be carried through space by the pressure of light. Today, panspermia is a serious area of study, supported by discoveries that suggest life's building blocks might be more widespread than we ever imagined. One of the strongest pieces of evidence for panspermia comes from the detection of organic molecules in space. Scientists have found amino acids, the building blocks of proteins, in meteorites that have fallen to Earth. These molecules are essential for life, as we know it, and their presence in space rocks suggests that the ingredients for life might be scattered across the cosmos. Even more intriguing is the discovery of complex organic compounds in the icy plumes of Saturn's moon, Enceladus, and the atmosphere of distant exoplanets. These findings hint that the universe might be filled with the raw materials needed for life to emerge, but how could life survive the harsh conditions of space? This is where extremophiles come in. These hardy microorganisms, found in some of Earth's most inhospitable environments, have shown an incredible ability to withstand extreme heat, cold, radiation, and even the vacuum of space. Experiments have shown that certain bacteria and fungi can survive for years on the exterior of the International Space Station, exposed to the full brunt of cosmic radiation and temperature swings. If life can endure such extremes, it's not hard to imagine it hitching a ride on a meteorite or comet, traveling vast distances and seeding a new world. One of the most famous examples of potential panspermia is the Martian meteorite ALH 84001. Discovered in Antarctica in 1984, this rock was later found to contain tiny structures that some scientists believe could be fossilized bacteria. While the debate over its origins continues, the possibility that life, or at least its precursors, could travel between planets is a tantalizing one. If Mars once harbored life, could it have sent microbial emissaries to Earth, sparking the beginnings of life here? Of course, panspermia isn't without its skeptics. Some argue that the journey through space would be too harsh for even the hardiest microbes, while others point out that we still don't fully understand how life originates, even with the right ingredients. But even if panspermia doesn't explain the origins of life on Earth, it still raises profound questions about the potential for life elsewhere. If life can spread across the cosmos, then planets like ours might not be isolated oases of biology. They could be part of a vast, interconnected web of living worlds. The idea of panspermia invites us to think bigger, to see life not as a singular event, but as a cosmic phenomenon. It challenges us to consider that the story of life on Earth might be just one chapter in a much larger narrative, written across the stars. And as we continue to explore the universe, searching for signs of life on distant worlds, we might just discover that the origins of life are more universal and more extraordinary than we ever imagined. What if the stories of gods descending from the skies in ancient myths weren't just stories? What if they were records of actual events, encounters with extraterrestrial beings who shaped the course of human history? This is the heart of the ancient astronaut theory, a provocative idea that suggests intelligent beings from beyond Earth visited our planet thousands of years ago, leaving behind clues in our myths, monuments, and even our DNA. While mainstream science often dismisses this theory as speculative, it has captured the imagination of millions, sparking debates about the origins of human civilization and the possibility of alien contact in our distant past. One of the most compelling pieces of evidence cited by proponents of the ancient astronaut theory comes from ancient texts and religious scriptures. Take, for example, the Hindu epic the Mahabharata, which describes flying machines called vimanas and weapons of unimaginable power. Or consider the biblical story of Ezekiel, who describes a fiery chariot descending from the heavens, complete with spinning wheels and beings with multiple faces. Could these accounts be metaphors, or are they descriptions of advanced technology witnessed by ancient peoples? Supporters of the theory argue that these stories, found in cultures across the globe, share striking similarities that suggest a common experience, one that might involve extraterrestrial visitors. Then there are the mysteries of ancient architecture. How did civilizations like the Egyptians or the Mayans, with their limited technology, construct monuments like the Great Pyramid of Giza or the precision-cut stones of Pumapunku? These structures, with their astronomical alignments and engineering feats, seem to defy the capabilities of their time. Could the knowledge to build them have come from an otherworldly source? Some theorists point to the intricate carvings and artifacts found at these sites, which depict figures wearing what appear to be helmets or suits, as potential evidence of alien influence. While skeptics argue that these interpretations are speculative, the questions they raise are undeniably intriguing, but the ancient astronaut theory doesn't stop at texts and monuments. It also delves into the realm of biology. Some researchers suggest that the sudden leap in human intelligence and creativity around 40,000 years ago, known as the Great Leap Forward, might have been the result of genetic manipulation by extraterrestrial beings. Could our ancestors have been uplifted by alien visitors, accelerating our evolution in ways that set us apart from other species? This idea, while controversial, taps into a deeper question about what it means to be human and how we came to be the dominant species on Earth. Of course, the ancient astronaut theory isn't without its critics. Many scientists argue that the evidence is anecdotal at best, and that the theory often relies on cherry-picked examples while ignoring more plausible explanations. For instance, the advanced engineering of ancient civilizations could be the result of lost human knowledge or techniques we've yet to fully understand. And the similarities in ancient myths, these could be explained by shared human experiences or the universal nature of storytelling, rather than direct contact with aliens. Yet, despite the skepticism, the theory persists, fueled by our fascination with the unknown and our desire to uncover the truth about our past. It challenges us to think differently about history, to consider that the answers we've always accepted might not be the whole story. And in doing so, it opens up new possibilities for how we see ourselves and our place in the universe. Whether you're a believer or a skeptic, the ancient astronaut theory invites us to explore the boundaries of what we know and to question the narratives we've been told. It's a reminder that history is not always as straightforward as it seems, and that the truth might be far stranger and more wondrous than we've ever imagined. As we continue to uncover the secrets of our past, we might just find that the line between myth and reality is thinner than we think. In October of 2017, astronomers made an extraordinary discovery, a strange object hurtling through our solar system at incredible speed. Named Oumuamua, which means scout or messenger in Hawaiian, this visitor was unlike anything we'd ever seen before. For starters, it wasn't from around here. Oumuamua was the first confirmed interstellar object ever observed passing through our cosmic neighborhood. But what made it truly fascinating were its peculiar characteristics, sparking debates that continue to this day. Was Oumuamua a natural phenomenon, or could it have been something far more extraordinary, a piece of alien technology? The first thing that stood out about Oumuamua was its shape. Most asteroids and comets in our solar system are roughly spherical or lumpy, but Oumuamua was different. Observations suggested it was elongated, possibly cigar-shaped, stretching hundreds of meters in length, but only a fraction of that in width. This unusual form raised eyebrows immediately. How did it form, and why was it so different from the objects we're used to seeing? Some scientists speculated that its shape might be the result of intense gravitational forces during its journey through space, while others wondered if it could be artificial in origin. Then there was the way Oumuamua moved. As it traveled through the solar system, it didn't just coast along under the influence of gravity, it accelerated. This behavior is typical of comets, which speed up as icy material on their surface vaporizes, creating a kind of natural jet propulsion. But here's the twist: Oumuamua showed no signs of outgassing. No visible tail, no coma, no dust cloud, nothing to explain its acceleration. This anomaly led some researchers, like Harvard astronomer Avi Loeb, to propose an even more radical idea. Could Oumuamua have been propelled by some kind of artificial means, like a light sail? These hypothetical structures, powered by sunlight or lasers, are often discussed as potential tools for interstellar travel. Could Oumuamua have been a piece of alien technology, silently gliding through the cosmos? Of course, not everyone is convinced. Many scientists argue that Oumuamua's strange behavior can be explained by natural processes. For instance, its acceleration might have been caused by the release of hydrogen gas trapped within its structure, a phenomenon that wouldn't produce the visible outgassing we associate with comets. Others suggest that Oumuamua could be a fragment of a larger object, shattered by a collision or tidal forces near its parent star. These explanations are more grounded in what we know about the universe, but they don't entirely account for all of Oumuamua's quirks. The truth is, we may never know for sure what this enigmatic object truly was. What makes Oumuamua so compelling isn't just the mystery of its origins, it's what it represents. This fleeting visitor reminded us that our solar system is not an isolated bubble. Objects from other star systems can and do pass through, carrying with them the potential for discovery. Oumuamua might have been a rock, a comet, or something else entirely, but its brief appearance has left a lasting impact on how we think about the universe. It's a reminder that the cosmos is full of surprises, and that even the smallest, most fleeting objects can challenge our understanding and spark our imagination. As we continue to scan the skies for more interstellar visitors, Oumuamua remains a symbol of possibility. Whether it was a natural wanderer or a deliberate messenger from another star, it has inspired us to keep looking, keep questioning, and keep dreaming. After all, the next time an object like Oumuamua passes by, we might just be ready to uncover its secrets, and perhaps in doing so, find answers to the greatest question of all: are we alone? Quantum physics has long been the realm of the mind-bending and the mysterious, a field where the rules of reality seem to bend and twist in ways that defy our everyday experiences. But what if this strange and counterintuitive world could offer insights into one of our greatest questions, the nature of alien life? As we dive into the intersection of quantum mechanics and astrobiology, we find ourselves exploring possibilities that stretch the boundaries of imagination, from quantum communication to the existence of parallel universes. Could advanced alien civilizations be leveraging quantum phenomena in ways we can't yet comprehend? Let's start with quantum communication. Here on Earth, scientists are already experimenting with quantum entanglement, a phenomenon Einstein famously called spooky action at a distance. When two particles become entangled, their properties are linked, no matter how far apart they are. Change one, and the other changes instantly, faster than the speed of light. This instantaneous connection has the potential to revolutionize how we transmit information. Now, imagine a civilization far more advanced than ours, one that has mastered quantum entanglement to create a galactic communication network. Messages could be sent across unimaginable distances without delay, bypassing the limitations of light-speed travel. If such a technology exists, it could explain why we haven't detected alien signals. They might be communicating in ways we're only beginning to understand. But quantum communication is just the tip of the iceberg. Quantum mechanics also introduces the concept of superposition, where particles can exist in multiple states at once until observed. This idea, while mind-boggling, raises intriguing questions about how life might function on a quantum level. Could alien organisms have evolved to harness superposition, allowing them to exist in multiple states or dimensions simultaneously? It's a wild thought, but one that challenges us to think beyond the constraints of our own biology. If life can thrive in environments we consider extreme, why not in states of existence we've yet to imagine? Then there's the idea of parallel universes, a concept rooted in the many worlds interpretation of quantum mechanics. According to this theory, every decision or event spawns a new universe, creating an infinite multiverse where every possible outcome exists. If this is true, could alien civilizations exist in these parallel realities, interacting with us in ways we can't perceive? Some scientists speculate that advanced beings might have developed the ability to traverse these universes, using quantum phenomena as a kind of cosmic highway. While this remains speculative, it's a fascinating lens through which to view the search for extraterrestrial intelligence. Of course, these ideas push the boundaries of what we know and what we can test. Quantum physics is notoriously difficult to study, and applying it to astrobiology adds another layer of complexity, but that's part of what makes this intersection so compelling. It forces us to think creatively, to consider that the answers we seek might lie not in the stars themselves, but in the fundamental fabric of reality. What's clear is that quantum physics offers a new way to approach the search for alien life. It reminds us that the universe is far stranger and more wonderful than we often assume. Advanced civilizations, if they exist, might not just be out there, they might be operating on a level of reality we're only beginning to glimpse. As we continue to explore the quantum world, we're not just uncovering the secrets of the cosmos, we're opening doors to possibilities that could redefine our understanding of life itself. And in that pursuit, the mysteries of quantum physics might just hold the key to answering one of humanity's oldest questions. Are we truly alone? When we look up at the night sky, we're seeing only a fraction of what's actually out there. The stars, planets, and galaxies we observe make up less than 5% of the universe. The rest, it's a cosmic mystery made up of dark matter and dark energy, two invisible forces that shape the very fabric of reality. But what exactly are these enigmatic components? And could they hold clues to the existence of alien civilizations? Let's unravel the mystery and explore how these unseen forces might influence the search for extraterrestrial intelligence. Dark matter, though invisible, is everywhere. It doesn't emit, absorb, or reflect light, making it undetectable by conventional means, yet its presence is undeniable. Without dark matter, galaxies wouldn't hold together, their stars would fly apart due to the immense speeds at which they orbit. This mysterious substance acts as a cosmic glue, binding galaxies and galaxy clusters together. But here's the intriguing part. If dark matter is so pervasive, could advanced alien civilizations have found ways to interact with it, or even harness it? Imagine a society that has unlocked the secrets of dark matter, using it to power their technology or even bend space and time. While this might sound like science fiction, the sheer abundance of dark matter in the universe makes it a tantalizing possibility. Then there's dark energy, an even more elusive force. Unlike dark matter, which pulls things together, dark energy is pushing the universe apart. It's the reason the cosmos is expanding at an accelerating rate, stretching the fabric of space itself. Dark energy makes up about 70% of the universe, yet we know almost nothing about it. Could alien civilizations have found ways to manipulate this force? Perhaps they've developed technologies that allow them to travel vast distances by riding the expansion of space, or even create localized regions where dark energy's effects are negated. The potential applications are as vast as the universe itself, limited only by our understanding, or lack thereof, but the connection between dark matter, dark energy, and alien life goes beyond speculation. These forces play a critical role in the formation and evolution of galaxies, which in turn influence where life might arise. Dark matter's gravitational pull helps galaxies form, while dark energy determines the large-scale structure of the universe. Without them, the cosmos as we know it wouldn't exist, and neither would the conditions necessary for life. Could alien civilizations have evolved in regions where dark matter or dark energy behave differently, creating environments we can't even imagine? It's a question that challenges our understanding of habitability and the diversity of life in the universe. Of course, unlocking the secrets of dark matter and dark energy is no small feat. Our current tools and theories are only beginning to scratch the surface, and much of what we know is based on indirect evidence. Projects like the Large Hadron Collider and space-based observatories, such as the James Webb and Euclid telescopes, are working to shed light on these cosmic mysteries. But what if advanced alien civilizations have already cracked the code? If they've mastered these forces, their technology might be so advanced that it operates on principles we can't yet comprehend. This raises an intriguing possibility. Could our inability to detect alien life be because they're using dark matter or dark energy in ways that are invisible to us? The search for dark matter and dark energy isn't just about understanding the universe. It's about understanding our place within it. These forces shape everything from the smallest particles to the largest structures, and they might hold the key to answering one of humanity's oldest questions: are we alone? As we continue to explore these cosmic enigmas, we're not just uncovering the secrets of the universe, we're opening doors to possibilities that could redefine our understanding of life itself. Whether dark matter and dark energy lead us to alien civilizations or remain a tantalizing mystery, one thing is certain: the journey to uncover their secrets is as thrilling as the destination. Time is a dimension we often take for granted, but in the search for alien civilizations, it becomes one of the most daunting challenges. The universe is over 13 billion years old, an unimaginable span that dwarfs the mere blip of human history. Within this vast cosmic timeline, civilizations could rise and fall, flourish and vanish, leaving behind only faint echoes of their existence. The question isn't just where to look for extraterrestrial life, it's when. Consider this: even if intelligent life is common in the universe, the odds of two civilizations existing at the same time are staggeringly low. A species might develop advanced technology, build cities, and explore the stars only to fade away millions of years before another civilization even emerges. The universe operates on a timescale so immense that our entire recorded history is less than a heartbeat in comparison. This raises a profound question: are we searching for aliens in the right era, or are we simply too early or too late? One of the biggest hurdles is the fleeting nature of technological civilizations. On Earth, humans have only been capable of sending signals into space for about a century, a mere blink in cosmic terms. If other civilizations follow a similar trajectory, their window of technological activity might be equally brief. Imagine a distant world where a civilization thrived for 1,000 years, sending out signals before collapsing or transitioning to a post-technological state. Their signals might still be traveling through space, but by the time they reach us, that civilization could be long gone. The universe is vast, but it's also ancient, and the search for alien life is as much a race against time as it is a search through space. Then there's the issue of cosmic synchronicity. Even if we detect a signal from another civilization, how do we know it's still there? A message from a star 1,000 light years away would take 1,000 years to reach us. By the time we receive it, the civilization that sent it might have vanished or evolved into something unrecognizable. The same applies to any signals we send out. Our first radio broadcasts are now traveling through space, but they've only reached a tiny fraction of the galaxy. If an alien civilization picks up our signals 1,000,000 years from now, will humanity even exist in a form they'd recognize? This temporal disconnect also complicates our search for physical evidence. Take, for example, the idea of megastructures like Dyson spheres. If an advanced civilization built such a structure billions of years ago, would it still be intact today? Over cosmic timescales, even the most durable constructions might erode, collapse, or be consumed by their dying stars. The evidence we're searching for might not just be distant, it might be ancient, degraded, or even unrecognizable. But time isn't just a barrier, it's also a source of hope. The universe's immense age means that life has had countless opportunities to arise and evolve. Civilizations might be rare, but over billions of years, the chances increase that at least a few have left behind detectable traces. The challenge is figuring out how to look for those traces, whether they're fossilized remains of ancient cities, long dormant megastructures, or faint signals echoing across the void. Ultimately, the role of time in the search for alien civilizations forces us to think differently about our place in the universe. It's a reminder that we're not just searching for life, we're searching for echoes of existence across the eons. The answers we seek might lie not just in the stars, but in the layers of cosmic history, waiting for us to uncover them. And as we continue to explore, we're not just asking whether we're alone, we're asking whether we've ever been alone, or whether we ever will be. It's a question that spans the past, present, and future, connecting us to the infinite tapestry of time itself. Picture this: two galaxies, each home to billions of stars and countless planets, locked in a slow, cosmic dance. Over millions of years, they spiral closer, their gravity pulling them together until they merge into one. This dramatic process, known as galactic cannibalism, is a common occurrence in the universe, and it raises a fascinating question. In the chaos of colliding galaxies, could alien civilizations survive or even thrive, or would they be swallowed up in the chaos, their worlds torn apart by the gravitational forces at play? Galactic cannibalism isn't just a spectacle, it's a fundamental part of how galaxies evolve. When a larger galaxy absorbs a smaller one, the results can be catastrophic for any planets caught in the crossfire. Stars and their planetary systems can be flung out of orbit, sent hurtling into the void, or crashing into one another. Habitable worlds, once teeming with life, might be ripped apart or rendered lifeless by the intense gravitational forces. For any civilizations living on these worlds, the merger could spell disaster, wiping them out in a cosmic blink. But amidst the destruction, there's also creation. Galactic mergers trigger bursts of star formation, as clouds of gas and dust collide and compress, igniting new stars and potentially new planets. These newborn worlds could become the cradles of life, offering fresh opportunities for civilizations to arise. Imagine a galaxy where the remnants of destroyed civilizations are replaced by new ones, rising from the ashes of the old. It's a cycle as old as the universe itself, destruction giving way to creation, and life finding a way to persist. For advanced civilizations, galactic mergers might present both challenges and opportunities. Those with the technology to predict and navigate these cosmic events could potentially avoid destruction, perhaps even harnessing the energy of the merger to fuel their societies. Imagine a civilization so advanced that it can move entire star systems, steering them away from danger or toward newly forming regions of the galaxy. Such a society might not just survive a galactic collision, it could thrive, using the chaos as a catalyst for growth and innovation. But what about civilizations that aren't so fortunate? For those without the means to escape or adapt, a galactic merger could be the end. Their worlds might be consumed, their histories erased, leaving behind only faint traces in the cosmic dust. This raises a somber possibility. Could the universe be littered with the remnants of civilizations that didn't survive the chaos of galactic cannibalism? And if so, how might we detect these lost civilizations, their stories whispered in the light of ancient stars? The mystery of galactic cannibalism isn't just about the fate of alien civilizations, it's also about our own. Our Milky Way is on a collision course with the Andromeda Galaxy, a merger that will take place in about 4 billion years. What does this mean for humanity? Could we, like the hypothetical civilizations we've imagined, find a way to survive and adapt, or will we, too, become a footnote in the cosmic story, our existence fleeting in the face of the universe's relentless evolution? As we ponder these questions, we're reminded of the vast, interconnected nature of the cosmos. Galactic cannibalism isn't just a destructive force, it's a creative one, shaping the universe in ways we're only beginning to understand. And in that shaping, it offers us a glimpse into the resilience and fragility of life itself. Whether civilizations rise or fall in the chaos of merging galaxies, their stories are woven into the fabric of the universe, a testament to the enduring quest for survival and discovery. And as we continue to explore the mysteries of the cosmos, we might just find that the answers we seek are written in the stars themselves. When we think about alien life, we often imagine beings with tentacles, glowing eyes, or advanced spaceships. But what about their minds? What would consciousness look like in a being from another world? This question takes us beyond biology and technology, diving into the realms of philosophy and neuroscience. Consciousness, our ability to experience, think, and perceive, is one of the most profound mysteries of existence. And if life exists elsewhere, it's almost certain that their consciousness would be as alien as their physical form. One of the most intriguing possibilities is the concept of a hive mind. Imagine a civilization where individual beings are connected in a vast, shared network of thought and experience. In Earth's own backyard, we see hints of this in social insects like ants and bees, which operate as a collective, almost like a single organism. But what if an alien species took this to the next level, with a consciousness so interconnected that individuality becomes blurred? For such a civilization, decision-making, creativity, and even identity might function in ways we can barely comprehend. Could they see the universe as a tapestry of interconnected thoughts rather than isolated minds? Then there's the idea of entirely new forms of awareness. On Earth, consciousness is tied to the physical brain, but what if alien beings evolved a different system altogether? Some scientists speculate that consciousness might not even require a brain as we know it. Could it emerge from a network of crystals, a swarm of nanobots, or even a planet-wide ecosystem? The possibilities are as limitless as the universe itself, challenging our assumptions about what it means to be conscious. But how would we even recognize alien consciousness if we encountered it? Our understanding of awareness is deeply rooted in human experience, making it difficult to imagine forms of thought that operate outside our framework. For example, an alien consciousness might perceive time differently, experiencing moments simultaneously rather than sequentially, or it might process emotions in ways we can't fathom, blending logic and feeling into a seamless whole. These differences could make communication, or even mutual recognition, incredibly challenging. The study of alien consciousness also raises profound questions about our own. If we were to encounter a being with a radically different form of awareness, how would it change our understanding of ourselves? Would we see our own minds as just one possibility among many, or would it deepen our appreciation for the unique way humans experience the world? Exploring these questions isn't just about understanding aliens, it's about understanding the nature of consciousness itself, and what it means to be alive in a universe filled with infinite possibilities. As we continue to search for life beyond Earth, the question of consciousness reminds us that the universe is not just a place of stars and planets, but of minds and experiences. Whether we encounter hive minds, time-bending awareness, or something entirely beyond our imagination, the discovery of alien consciousness could be one of the most transformative moments in human history. It would challenge us to rethink not just who we are, but what it means to think, feel, and exist in a cosmos that is far stranger and far more wondrous than we've ever imagined. Imagine a planet adrift in the void of space, untethered to any star, floating through the darkness like a cosmic nomad. These are rogue planets, worlds that have been ejected from their solar systems or formed on their own, wandering the galaxy without the warmth of a parent star. At first glance, they seem like barren, frozen wastelands, but what if these lonely worlds hold secrets we've yet to uncover? Could life, or even entire civilizations, exist on these wandering planets, thriving in ways we've never imagined? One of the most intriguing possibilities is the presence of subsurface oceans. Without the heat of a star, rogue planets would be incredibly cold on the surface, but deep beneath their icy exteriors, geothermal heat could create pockets of liquid water. This internal warmth, generated by the planet's own radioactive decay or gravitational interactions, might be enough to sustain life. Think of Europa or Enceladus, moons in our own solar system with subsurface oceans. Rogue planets could be similar, but on a much larger scale. These hidden oceans could host ecosystems unlike anything on Earth, adapted to thrive in complete darkness and extreme pressure. But how could life survive without sunlight, the energy source that fuels almost all life on our planet? The answer might lie in chemosynthesis, a process where organisms derive energy from chemical reactions rather than sunlight. On Earth, we've found life thriving in the deepest, darkest parts of the ocean, around hydrothermal vents that spew minerals and heat. These extremophiles rely on sulfur and other chemicals, not sunlight, to survive. If rogue planets have similar geothermal activity, they could harbor life forms that have evolved to tap into these energy sources, creating entire ecosystems in the absence of a star. Then there's the question of atmosphere. Without a star, how could a rogue planet maintain an atmosphere capable of supporting life? Some scientists suggest that these worlds might have thick, insulating atmospheres composed of gases like hydrogen or methane, trapping heat and creating stable conditions beneath the surface. Others propose that rogue planets could be part of binary systems, where two planets orbit each other, generating heat through gravitational friction. These interactions could keep the planets warm enough to sustain liquid water, and possibly life for billions of years. But what about intelligent life? Could advanced civilizations exist on rogue planets, hidden beneath miles of ice or in vast subterranean cities? It's a fascinating thought. A civilization on a rogue planet might develop technologies we can't yet imagine, harnessing geothermal energy or even tapping into the planet's internal heat to power their societies. They might have evolved in complete isolation, their cultures and technologies shaped by the unique challenges of living on a world without a star. The idea raises profound questions about the diversity of life in the universe and the conditions under which intelligence can emerge. Of course, rogue planets present their own set of challenges for detection. Without a star, they don't emit much light, making them incredibly difficult to spot. Most of what we know about these nomadic worlds comes from gravitational microlensing, a phenomenon where their gravity bends and magnifies the light of distant stars. But as our technology improves, we're beginning to uncover more of these hidden worlds, and with each discovery, the possibility of life on rogue planets becomes a little less speculative. The mystery of rogue planets reminds us that life, in all its forms, is incredibly resilient and adaptable. It challenges us to think beyond the familiar, to imagine worlds where the rules of habitability are rewritten. Whether these wandering planets are barren or teeming with life, they offer a glimpse into the boundless creativity of the cosmos. As we continue to explore the universe, rogue planets stand as a testament to the endless possibilities that await us, hidden in the darkness between the stars. And who knows, the next great discovery in our search for alien life might not come from a planet orbiting a star, but from one drifting alone, carrying its secrets through the vast expanse of space. Interstellar travel, the idea of journeying between stars, has long been a staple of science fiction, but could it be a reality for advanced alien civilizations? The distances between stars are mind-boggling, with even the closest star systems lying trillions of miles away. For us, such journeys seem impossible with current technology, but what about civilizations that might be thousands or even millions of years ahead of us? How could they bridge the vast gulfs of space, and if they can, why haven't we encountered them yet? Let's explore the possibilities. One of the most intriguing concepts is the warp drive, a theoretical propulsion system that could allow a spacecraft to travel faster than the speed of light. The idea, popularized by science fiction, isn't entirely out of reach. According to some interpretations of Einstein's theory of relativity, it might be possible to distort space-time itself, creating a bubble that moves faster than light without breaking the laws of physics. While this remains purely theoretical, the idea that advanced civilizations could have mastered such technology is tantalizing. Imagine a species capable of bending the fabric of space, traversing the galaxy in what would feel like moments. If warp drives are possible, they could explain how aliens might visit distant stars, and perhaps even Earth, but what if faster-than-light travel is impossible? Another approach is the generation ship, a massive vessel designed to sustain a population over centuries or even millennia. These ships would essentially become self-contained worlds, with generations of travelers living and dying aboard as they journey to a distant star. It's a slower, more methodical approach, but for civilizations with long lifespans or a deep sense of patience, it could be a viable option. The idea of a generation ship raises fascinating questions about the social and psychological challenges of such a journey. How would a civilization maintain its culture and identity over such a long span? And what would happen when they finally reached their destination? Then there's the concept of sleeper ships, where travelers are placed in suspended animation for the duration of the journey. This idea, often seen in science fiction, could allow a crew to survive the vast timescales of interstellar travel without the need for generational continuity. Advanced cryogenic technology or even biological hibernation could make this possible, offering a way to pause life during the long voyage. For a civilization with the ability to manipulate biology at a fundamental level, such a method might be a practical solution to the challenges of crossing the stars. But even if interstellar travel is achievable, why haven't we seen evidence of it? One possibility is that advanced civilizations might be incredibly rare, spread so thinly across the galaxy that contact is unlikely. Another is that they might be intentionally avoiding us, adhering to a kind of cosmic, prime directive to prevent interference with less developed species. Or perhaps their methods of travel are so advanced that they are undetectable to our current technology. They might be using wormholes, hyperspace, or other phenomena we've yet to discover, leaving no trace of their passage through the cosmos. The idea of interstellar travel doesn't just challenge our understanding of physics, it challenges our understanding of time, culture, and the very nature of exploration. If aliens can travel between stars, it suggests a level of technological and societal sophistication that's difficult to comprehend, and if they haven't visited us yet, it raises profound questions about our place in the universe. Are we too insignificant to notice, or are we being deliberately ignored? The search for answers isn't just about finding aliens, it's about understanding the potential for connection across the vastness of space and what it means to be part of a universe filled with possibilities. As we continue to explore the mysteries of interstellar travel, we're reminded that the universe is full of surprises. The methods we imagine today might be the stepping stones to discoveries that reshape our understanding of what's possible. And whether aliens are using warp drives, generation ships, or something beyond our wildest dreams, the pursuit of these ideas pushes us to think bigger, to dream of a future where the stars are no longer out of reach. The journey to uncover the secrets of interstellar travel isn't just about finding others, it's about discovering what we're capable of and what lies beyond the next horizon. What if the universe is not just a place of stars and planets, but also a graveyard of civilizations that once thrived? This is the intriguing premise of cosmic archaeology, a field that seeks to uncover the remnants of ancient alien societies. Unlike traditional archaeology, which digs into Earth's past, cosmic archaeology looks to the stars, searching for ruins, artifacts, or any traces of intelligence that might have existed long before humanity. But how do you search for something that might be millions, or even billions of years old, scattered across the unimaginable vastness of space? The first challenge is scale. The universe is staggeringly large, with billions of galaxies, each containing billions of stars and planets. Even within our own Milky Way, the distances are so immense that finding evidence of ancient civilizations feels like searching for a needle in a cosmic haystack. And that's assuming such evidence still exists. Over cosmic timescales, even the most durable structures like megacities or massive engineering projects could erode, collapse, or be consumed by their dying stars. The remnants we're searching for might be faint, degraded, or even unrecognizable, blending seamlessly into the natural landscape of the universe. Then there's the question of what we're actually looking for. On Earth, archaeologists rely on physical artifacts, tools, pottery, buildings, to piece together the story of ancient cultures, but in space, the definition of an artifact becomes far more abstract. Could it be a Dyson sphere, a megastructure designed to harness the energy of a star, or perhaps an abandoned spacecraft drifting silently through the void? Some scientists have even speculated about stellar engineering, where advanced civilizations might alter the behavior of stars or black holes in ways that leave detectable traces. These ideas push the boundaries of what we consider evidence, forcing us to think creatively about the kinds of clues ancient aliens might leave behind. One of the most promising avenues in cosmic archaeology is the search for technosignatures, signs of technology or industrial activity. For example, a planet with unusual levels of atmospheric pollution might indicate the presence of an industrial civilization, even if that civilization is long gone. Telescopes like the James Webb Space Telescope are now capable of analyzing the atmospheres of distant exoplanets, looking for chemical anomalies that could hint at past or present intelligence. Similarly, unusual light patterns around stars like those seen with Tabby's star might suggest the presence of massive artificial structures. These kinds of observations could provide the first hints of cosmic archaeology's ultimate prize, the discovery of an ancient alien civilization. But even if we find something, how would we know it's artificial? Distinguishing between natural phenomena and the handiwork of aliens is no easy task. A strange signal or unusual structure could have countless natural explanations, from stellar flares to cosmic dust clouds. To avoid false positives, cosmic archaeologists must carefully analyze their findings, ruling out every possible natural explanation before considering an artificial one. It's a painstaking process, but one that's essential for ensuring the credibility of any discoveries. The search for alien ruins isn't just about finding answers, it's about understanding our place in the universe. If we were to uncover evidence of a long-dead civilization, it would mean that intelligence and technology are not unique to humanity. It would suggest that civilizations rise and fall across the cosmos, leaving behind echoes of their existence. And it would challenge us to think differently about our own future. Are we destined to become another cosmic footnote, or can we find a way to endure, leaving our own mark on the universe? As we continue to explore the cosmos, cosmic archaeology reminds us that the universe is not just a place of stars and planets, it's a place of stories. Every star, every galaxy, every strange signal could hold the key to unlocking one of those stories, revealing the triumphs and tragedies of civilizations that came before us. The search for alien ruins is a journey into the unknown, a quest to uncover the traces of those who might have once looked up at the same stars and asked the same questions. And in that search, we're not just looking for aliens, we're looking for ourselves and the endless possibilities that lie ahead. If we ever make contact with an alien civilization, one of the first and most profound challenges we'll face is communication. How do you talk to someone or something whose language, culture, and even way of thinking might be completely foreign to anything we've ever encountered? The idea of interstellar communication isn't just about exchanging words, it's about bridging the gap between worlds, finding a way to share ideas across the vast gulfs of space, time, and biology. So, how do we even begin to approach such a monumental task? Mathematics and physics often serve as the starting point for discussions about universal communication. These disciplines are rooted in constant numbers, equations, and laws that are the same no matter where you are in the universe. The ratio of a circle's circumference to its diameter, the speed of light, the structure of atoms. These are concepts that any technologically advanced civilization would likely understand. That's why many proposed messages to aliens, like the Arecibo Message, rely heavily on mathematical and scientific principles. But while math and physics provide a common language, they only scratch the surface of what communication could entail. How do you express emotions, culture, or abstract ideas through numbers and equations? This is where things get tricky. Language isn't just a tool for sharing facts, it's deeply tied to culture, history, and even the biology of the species using it. Human languages, for example, are shaped by the way our brains process information, the sounds our vocal cords can produce, and the social structures we've built over millennia. An alien civilization might not even use sound to communicate. They could rely on light, chemicals, or even patterns of electromagnetic waves. Their language might not have nouns or verbs as we understand them, or it might be so abstract that it defies translation. The very concept of a conversation could be alien to them. Then there's the question of intent. Even if we manage to decode an alien language, how do we know what they're trying to say? A simple message could carry layers of meaning, shaped by cultural nuances we can't begin to comprehend. For example, a gesture or symbol that's friendly to us might be interpreted as hostile or offensive by an alien species. Miscommunication on a cosmic scale could have serious consequences, which is why many scientists advocate for caution in our attempts to reach out. The stakes are high, and the margin for error is slim. But what if we could create a universal language, one that transcends biology and culture? Some researchers have proposed using visual symbols, like pictograms or diagrams, to convey basic concepts. These symbols could represent universal ideas like danger, cooperation, or curiosity, in a way that's intuitive to any intelligent being. Others suggest using music or art, relying on patterns and rhythms that might resonate across species. The Voyager Golden Record, for instance, included sounds and images meant to represent Earth and humanity, offering a kind of interstellar Rosetta Stone for any civilization that might find it. Of course, even the most carefully crafted message carries no guarantee of being understood. The very act of attempting communication assumes that aliens think in ways we can relate to, a big assumption when dealing with beings that might be as different from us as we are from ants. Yet the effort itself is meaningful. By reaching out, we're not just trying to talk to aliens, we're demonstrating our curiosity, our creativity, and our desire to connect. It's a reflection of who we are as a species and what we hope to find in the universe. The challenge of communicating with aliens forces us to confront the limits of our own understanding. It's a reminder that language is more than just words. It's a window into how we see the world and how others might see it differently. Whether we ever succeed in having a conversation with extraterrestrials, the pursuit itself enriches our perspective, pushing us to think beyond the boundaries of Earth and imagine the infinite possibilities of connection across the stars. And in that effort, we might just discover something profound about ourselves. The universe is a place of unimaginable scale, where stars burn for billions of years and galaxies stretch across unfathomable distances. But what if, hidden among the stars, there are structures so vast and complex that they defy our understanding? Structures built not by nature, but by civilizations far more advanced than our own. These are cosmic megastructures, hypothetical constructs like Dyson spheres, ring worlds, or even stellar engines designed to harness the energy of entire star systems. The idea of such colossal engineering projects isn't just the stuff of science fiction. It's a serious, scientific concept that could hold the key to finding intelligent life beyond Earth. Let's start with the Dyson sphere, perhaps the most famous of these megastructures. Proposed by physicist Freeman Dyson in the 1960s, this concept imagines a civilization so advanced that it builds a shell or swarm of satellites around its star to capture its energy output. The idea is both elegant and practical. By harnessing the full power of a star, a civilization could meet its energy needs for millennia. But here's the catch: a Dyson sphere would block a significant portion of the star's light, creating a distinct infrared signature as the absorbed energy is re-emitted as heat. This is what astronomers look for when scanning the sky's stars that seem unusually dim but emit excess infrared radiation, a potential sign of alien engineering. Then there's the ring world, a concept popularized by science fiction but rooted in real physics. Picture a massive ring orbiting a star, its inner surface covered in habitable land, water, and atmosphere. Such a structure would be a marvel of engineering, providing living space on a scale that dwarfs even the largest planets. But building a ring world would require materials and technology far beyond our current capabilities, raising questions about the kind of civilization that could pull it off. Could these structures exist, or are they just theoretical pipe dreams? The answer might lie in the faint traces they leave behind, detectable through advanced telescopes and meticulous observation. But detecting megastructures isn't as simple as looking for a star that's too dim or too bright. The universe is full of natural phenomena that can mimic the signs of alien engineering. Dust clouds, for example, can obscure starlight and emit infrared radiation, creating signals that resemble a Dyson sphere. Similarly, irregular light patterns around stars might be caused by natural processes like stellar flares or orbiting debris, rather than massive artificial constructs. This makes the search for megastructures a delicate balancing act, requiring scientists to carefully rule out natural explanations before considering the extraordinary. One of the most intriguing aspects of megastructures is what they reveal about the civilizations that might build them. Constructing something on this scale would require not only advanced technology, but also a level of cooperation and ambition that's difficult to comprehend. It suggests a civilization that's thinking on a cosmic timescale, planning for the long-term survival of its species, but it also raises ethical questions. Would such a civilization be peaceful, focused on sustainability and exploration, or would it be driven by expansion and conquest, seeking to dominate the stars? The answers might depend on how we interpret the evidence and how we approach the idea of contact. The search for megastructures isn't just about finding aliens, it's about expanding our understanding of what's possible. These hypothetical constructs challenge us to think bigger, to imagine civilizations that have transcended the limits of planetary living. They remind us that the universe is not just a place of stars and planets, but of potential, a canvas where intelligence and creativity can reshape the very fabric of reality. And as we continue to explore, we might just find that the answers we seek are written not in the stars themselves, but in the traces of those who dared to build among them. So, could cosmic megastructures be the key to finding intelligent life? The answer is as vast and complex as the universe itself, but one thing is certain: the search for these colossal constructs is more than a scientific endeavor. It's a journey into the unknown, a quest to uncover the limits of possibility and the boundless creativity of the cosmos. And in that search, we're not just looking for aliens, we're discovering what it means to dream, to explore, and to imagine a future among the stars. The search for alien life isn't just a scientific endeavor, it's an ethical frontier. As we reach out into the cosmos, we're forced to confront questions that go beyond telescopes and data. What responsibilities do we have if we discover intelligent life? Should we make contact, or would doing so risk unintended consequences? These aren't hypothetical musings, they're urgent considerations that could shape the future of humanity and any civilizations we might encounter. One of the most immediate ethical dilemmas revolves around the act of communication itself. Think about it. If we detect a signal from an alien civilization, how should we respond? Broadcasting a reply could open the door to an extraordinary exchange of knowledge, but it could also reveal our existence to a species with unknown intentions. This isn't just about curiosity, it's about survival. The stakes are so high that some scientists, like Stephen Hawking, have warned against initiating contact without careful thought. After all, history has shown us that encounters between civilizations of vastly different technological levels rarely end well for the less advanced one. Could humanity be risking its own safety in a bid to connect with the stars? Then there's the concept of non-interference, popularized by science fiction, but rooted in real ethical principles. Star Trek's Prime Directive, for example, dictates that advanced civilizations should avoid interfering with the development of less advanced ones. While it's a fictional idea, it raises a valid point. Should we impose our presence on a civilization that isn't ready for it? Imagine discovering a planet teeming with life, but still in its early stages of evolution. Would it be ethical to make contact, potentially disrupting their natural development? Or should we observe from afar, allowing them to grow and evolve on their own terms? These questions challenge us to consider not just what we can do, but what we should do. The ethics of colonization add another layer of complexity. As humanity looks to the stars for new homes, we must ask, what happens if we find a planet already inhabited by life, even if it's microbial? Do we have the right to settle there, potentially altering or destroying ecosystems that have existed for millennia? This isn't just a question of survival, it's a question of respect. If we're willing to prioritize our own needs over the existence of other life forms, what does that say about our values as a species? Some argue that colonization could be justified if it ensures humanity's survival, while others believe it's our moral duty to preserve the integrity of any life we encounter, no matter how primitive. But what about the potential benefits of contact? Discovering an alien civilization could bring unprecedented advancements in science, technology, and philosophy. Sharing knowledge with a species that has evolved independently of Earth could revolutionize our understanding of the universe. It could also foster a sense of unity, reminding us that we're part of something far greater than our own planet. The ethical challenge lies in balancing these potential benefits with the risks. Is it possible to engage with an alien civilization in a way that's mutually beneficial, or are the dangers too great to justify the attempt? At its core, the search for alien life forces us to reflect on who we are and who we want to be. It's not just about finding answers, it's about asking the right questions. How do we define our responsibilities as explorers of the cosmos? What kind of legacy do we want to leave in the universe? These ethical dilemmas don't have easy answers, but they're essential to consider as we take our first steps into the unknown. After all, the decisions we make today could echo across the stars for generations to come, shaping not just our future, but the future of any civilizations we might encounter. And in that journey, we're not just searching for aliens, we're searching for the best version of ourselves. Imagine shouting into a void, your voice echoing endlessly, waiting for a reply that never comes. This is the essence of the Fermi Paradox, the puzzling silence that greets our efforts to connect with extraterrestrial civilizations. Despite decades of scanning the skies, sending out signals, and exploring the cosmos, we've yet to hear a single whisper from beyond our planet. The question isn't just why we haven't found aliens, it's why they haven't found us. What could explain this cosmic quiet, and what does it say about our place in the universe? One possibility is that intelligent life is incredibly rare. The universe is vast, with billions of galaxies, each containing billions of stars and planets. Yet, the conditions necessary for life to arise and evolve into intelligence might be so specific that they're almost impossible to replicate. Think about it. Earth's history is filled with chance events, asteroid impacts, climate shifts, and evolutionary quirks that shape the course of life. If even one of these factors had been different, humanity might never have existed. Could it be that the odds of intelligent life emerging elsewhere are so slim that we're essentially alone in the cosmos? But rarity isn't the only explanation. Another chilling possibility is the Great Filter, a hypothetical barrier that prevents civilizations from reaching the stars. This filter could lie in our past, meaning that the emergence of intelligent life is extraordinarily unlikely. Or more ominously, it could lie ahead of us, suggesting that advanced civilizations inevitably destroy themselves before making contact with others. Whether through nuclear war, environmental collapse, or technological catastrophe, the idea of self-destruction looms large in discussions about the Fermi Paradox. If this is true, the silence might not just be about aliens. It could be a warning for humanity's own future. Then there's the possibility that we're simply not listening in the right way. Our current methods of searching for alien signals rely heavily on radio waves. But what if advanced civilizations use entirely different forms of communication? Imagine a species that communicates through quantum entanglement, manipulating particles across vast distances, or one that uses technologies we haven't even conceived of yet. Our attempts to detect them might be like trying to hear a symphony with our ears plugged. The problem isn't that they're not speaking, it's that we're not equipped to understand their language. Another intriguing idea is that alien civilizations might be intentionally avoiding contact. Perhaps they're observing us from a distance, adhering to a kind of cosmic, prime directive to avoid interfering with less advanced species. Or maybe they've evolved beyond the need for physical exploration, existing in forms we can't detect or comprehend. This concept, often referred to as the zoo hypothesis, suggests that we're not alone. We're just being left alone, either out of respect or indifference. Of course, there's also the possibility that we're simply too early or too late. The universe is over 13 billion years old, and civilizations could rise and fall on timescales that make our existence seem fleeting. If another civilization existed millions of years ago, their signals might have already passed us by, lost in the vastness of space. Similarly, if intelligent life is just beginning to emerge elsewhere, it could be millennia before they develop the technology to communicate across the stars. In this scenario, the silence isn't a sign of absence, it's a matter of timing. The mystery of cosmic silence isn't just a scientific puzzle, it's a philosophical one. It forces us to confront our assumptions about life, intelligence, and the nature of the universe itself. Are we truly alone, or is the cosmos teeming with civilizations we've yet to discover? The answer might lie in the stars, in the faint whispers of signals we've yet to detect, or in the quiet spaces between them. As we continue to search, we're not just looking for aliens, we're searching for a deeper understanding of our place in the universe and the endless possibilities that await us. And in that search, the silence itself might be the most profound message of all. What if the search for alien life didn't just challenge our understanding of science, but also our understanding of faith? For millennia, religions have offered answers to life's biggest questions. Who are we? Why are we here? What lies beyond? The discovery of extraterrestrial intelligence would shake the foundations of these beliefs, forcing us to reconsider how we see ourselves and our place in the cosmos. How might different faiths respond to such a revelation, and could the search for alien civilizations lead to a new era of spiritual exploration? Let's start with Christianity, a faith built on the belief in a divine creator and the unique role of humanity as God's creation. For many Christians, the idea of alien life raises profound theological questions. If life exists elsewhere, does it share the same relationship with God? Would extraterrestrials have souls, and if so, would they be part of the same salvation story? Some theologians argue that the discovery of aliens wouldn't contradict Christian teachings, but instead expand them, suggesting that God's creation is far more vast and diverse than we've imagined. Others, however, might see it as a challenge to humanity's special place in the universe, sparking debates about how to reinterpret sacred texts in light of new discoveries. Islam, with its emphasis on the unity and omnipotence of Allah, offers another perspective. The Quran speaks of God as the creator of all worlds, a phrase that some interpret as a nod to the possibility of life beyond Earth. For many Muslims, the existence of aliens could be seen as a testament to Allah's infinite power and creativity, reinforcing rather than undermining their faith. At the same time, the discovery would likely prompt deep discussions about the nature of creation and humanity's role within it. Would extraterrestrials be subject to the same moral laws as humans, or would they have their own divine guidance? In Hinduism, the concept of multiple worlds and beings is already woven into the fabric of its cosmology. The ancient texts describe countless universes, each with its own gods, demons, and inhabitants. For Hindus, the discovery of alien life might not be as disruptive as it would be for other faiths. Instead, it could be seen as a confirmation of what their scriptures have long suggested, that the universe is teeming with life in all its forms. This perspective could foster a sense of cosmic unity, connecting humanity to a broader tapestry of existence, but not all religious traditions would respond with such openness. Some might view the discovery of aliens as a test of faith, challenging believers to hold firm to their convictions in the face of new realities. Others could see it as an opportunity for dialogue, using the revelation to explore the intersections of science and spirituality. The question isn't just how religions would react, it's how they would evolve. Could the search for alien civilizations lead to a new understanding of divinity, one that transcends the boundaries of Earth and embraces the infinite possibilities of the cosmos? The implications extend beyond theology to the very nature of spirituality itself. If we're not alone in the universe, what does that mean for our sense of purpose? Would the discovery of alien life inspire a renewed sense of wonder and humility, or would it leave us feeling small and insignificant? These are questions that go beyond doctrine, touching on the core of what it means to be human. The search for extraterrestrial intelligence isn't just a scientific endeavor, it's a spiritual journey, one that invites us to explore the deepest mysteries of existence. As we ponder these questions, we're reminded that the search for alien life isn't just about finding answers. It's about challenging assumptions, sparking conversations, and expanding our horizons. Whether it leads to a new understanding of faith or a reimagining of our place in the universe, the discovery of extraterrestrial intelligence would be a moment of profound transformation. It's a reminder that the cosmos is not just a place of stars and planets, but of endless possibilities waiting to be explored, and in that exploration, we might just find a deeper connection to the divine and to ourselves. The universe is a story, a grand, unfolding narrative of transformation and growth, from the birth of stars to the emergence of planets, and from the first spark of life to the rise of intelligence. Cosmic evolution paints a picture of a universe constantly moving toward greater complexity. It's a process that seems almost inevitable, a natural progression from simplicity to sophistication. But if this is true, if the universe is wired to produce life and intelligence, why haven't we found any evidence of it beyond Earth? This is the mystery of cosmic evolution, and it's a question that challenges everything we think we know about our place in the cosmos. Let's start with the basics. Cosmic evolution begins with the Big Bang, the moment when the universe burst into existence, filled with nothing but energy and the simplest elements. Over billions of years, gravity pulled matter together, forming stars and galaxies. Within these stellar nurseries, heavier elements like carbon, oxygen, and nitrogen were forged, the building blocks of life as we know it. When these stars died, they scattered their elements across the cosmos, seeding the next generation of stars and planets. It's a cycle as old as the universe itself, one that has given rise to countless worlds, including our own. But here's the fascinating part. Cosmic evolution doesn't stop at the formation of planets. On some of these worlds, the right conditions come together: liquid water, a stable climate, and the right chemical ingredients to spark the emergence of life. And once life begins, it seems to follow its own evolutionary path, driven by the same forces that shape the stars. From single-celled organisms to complex ecosystems, and eventually to conscious beings capable of asking questions about their own existence, life appears to be another step in the universe's journey toward complexity. This raises a profound question. Is intelligence an inevitable outcome of cosmic evolution? Some scientists argue that it is. They point to the fact that, given enough time and the right conditions, life tends to evolve in ways that maximize its ability to adapt and survive. Intelligence, with its capacity for problem-solving and innovation, might simply be the next logical step in this process. If that's the case, then the universe could be teeming with civilizations, each one a product of the same cosmic forces that shaped us. Yet, if intelligence is so inevitable, why haven't we found any signs of it? This is the heart of the mystery. One possibility is that intelligence is rare, even in a universe filled with life. The path from single-celled organisms to conscious beings might be filled with obstacles, catastrophic events, evolutionary dead ends, or simply the immense timescales required for intelligence to emerge. Another possibility is that intelligent civilizations are short-lived, destroying themselves before they have a chance to make their presence known. Whether through war, environmental collapse, or technological catastrophe, the window of opportunity for contact might be vanishingly small. But there's also the chance that we're looking in the wrong way, or in the wrong places. Our current methods of searching for alien life are limited, focused primarily on detecting signals or signs of technology. What if advanced civilizations communicate in ways we can't yet detect, or exist in forms we can't recognize? The universe is vast and strange, and the possibilities are as limitless as the stars themselves. The mystery of cosmic evolution isn't just about finding aliens. It's about understanding the nature of the universe and our place within it. It challenges us to think differently about life, intelligence, and the forces that shape existence. And as we continue to explore, we're not just searching for answers, we're uncovering the story of the cosmos itself, a story that's still being written. Whether we're alone or part of a vast, interconnected web of life, one thing is certain: the journey to uncover the truth is as extraordinary as the truth itself. Imagine being able to test the boundaries of life itself, not in a lab, but in a digital universe where the rules of reality can be bent, tweaked, and rewritten. This is the power of simulations, a cutting-edge tool that's revolutionizing our understanding of alien life. By creating virtual models of planets, atmospheres, and even hypothetical alien species, scientists are exploring scenarios that would be impossible to replicate in the real world. These simulations aren't just about satisfying curiosity. They're about preparing for the extraordinary possibility that we're not alone in the universe. At the heart of this approach is the ability to model planetary environments. Take, for example, the search for habitable exoplanets. With thousands of these distant worlds discovered, scientists use simulations to predict which ones might support life. By inputting data on a planet's size, composition, and distance from its star, they can simulate everything from surface temperatures to atmospheric pressure. These virtual experiments help narrow down the list of promising candidates, guiding telescopes like the James Webb Space Telescope to focus on the most likely targets. It's like having a crystal ball for space exploration, one that lets us peek into the conditions of worlds light years away. But simulations don't stop at analyzing planets. They also explore the potential behaviors of alien life forms. Biologists and astrobiologists are using computational models to hypothesize how extraterrestrial organisms might evolve and adapt to their environments. For instance, what kind of life could exist on a planet with a methane-based atmosphere instead of oxygen? Or how might creatures evolve in the crushing pressures of a subsurface ocean? These simulations allow scientists to think creatively, testing scenarios that push the boundaries of what we consider life. It's a way of asking, what if? Without the constraints of Earth-bound biology, one of the most exciting applications of simulations is their role in preparing for contact with extraterrestrial intelligence. How would we communicate with a species that doesn't share our language, culture, or even biology? By simulating first contact scenarios, researchers can explore strategies for bridging these gaps. For example, simulations might test how to decode a signal from an alien civilization, or how to respond in a way that minimizes misunderstandings. These exercises aren't just academic, they're practical steps toward ensuring that, if we ever do make contact, we're ready to handle it with care and respect. Of course, simulations aren't without their limitations. No matter how advanced the technology, they're still based on our current understanding of science and biology, which is inherently limited by what we know about life on Earth. This means that while simulations can provide valuable insights, they can't account for the full range of possibilities that might exist in the cosmos. Still, they offer a powerful way to explore the unknown, helping us think beyond our own experiences and imagine the unimaginable. The role of simulations in the search for alien life is more than just a scientific tool, it's a mindset. It's about embracing the unknown, using creativity and technology to explore the edges of what's possible. Whether it's modeling the atmospheres of distant planets or preparing for the day we might meet an alien species, simulations remind us that the universe is full of surprises. And as we continue to refine these tools, we're not just preparing for the future, we're expanding our understanding of life itself, one virtual experiment at a time. Hidden within the vastness of space and time, there may lie secrets from civilizations long gone, messages and artifacts waiting to be discovered. These cosmic time capsules, whether they're ancient ruins buried beneath alien soil or signals encoded in the light of distant stars, could hold the key to unlocking the mysteries of extraterrestrial life. But what exactly are we looking for, and how do we begin to search for relics that might be millions, or even billions, of years old? One of the most fascinating ideas is the concept of buried ruins on other planets or moons. Imagine a world where an advanced civilization once thrived, leaving behind cities, monuments, or even entire infrastructures. Over time, these structures could have been buried by natural processes like erosion, volcanic activity, or shifting tectonics. For example, on Mars, the planet's surface is littered with evidence of ancient rivers, lakes, and possibly even oceans. If life ever existed there, could it have left behind remnants of its presence? Rovers like NASA Perseverance are already scouring the Martian landscape, searching for signs of past life. But what if they stumble upon something more, an artifact or structure that points to intelligence rather than just biology? The discovery of such a relic would be a game changer, rewriting our understanding of the universe and our place within it. But cosmic time capsules aren't just physical objects, they could also be encoded in the very fabric of the cosmos. Starlight, for instance, carries a wealth of information about the stars and planets it passes through. Could advanced civilizations have embedded messages in the light of their stars, creating a kind of interstellar Morse code? This idea, while speculative, isn't as far-fetched as it sounds. Scientists have already used starlight to analyze the atmospheres of exoplanets, searching for chemical signatures that might indicate life. If aliens wanted to leave a message for the universe, they might use similar methods, encoding information in the subtle variations of light or radiation. Detecting such a signal would require incredibly sensitive instruments, but the payoff could be immense, a direct message from a civilization that might no longer exist. Another possibility is that time capsules are hidden in plain sight, embedded in the natural phenomena of the universe. For example, pulsars rapidly spinning neutron stars emit regular bursts of radio waves with astonishing precision. Some scientists have suggested that these signals could be used as cosmic lighthouses, guiding interstellar travelers or even serving as a form of universal communication. If an advanced civilization had the ability to manipulate these natural signals, they could encode information in the timing or intensity of the pulses. This would be a subtle yet powerful way to leave a mark on the universe, one that could endure for billions of years. Of course, searching for cosmic time capsules isn't without its challenges. The universe is unimaginably vast, and the relics we're looking for might be incredibly faint or degraded by time. Distinguishing between natural phenomena and artificial constructs is no easy task, especially when dealing with signals or structures that are billions of years old. Yet, the very difficulty of the search makes it all the more compelling. It's a reminder that the universe is a place of endless possibilities, where even the faintest whisper of the past could hold profound significance. The search for cosmic time capsules isn't just about finding aliens, it's about connecting with the history of the universe itself. These relics, whether they're physical artifacts or encoded signals, offer a window into the lives of civilizations that might have risen and fallen long before humanity even existed. They remind us that the cosmos is not just a place of stars and planets, but of stories, countless narratives waiting to be uncovered. And as we continue to explore, we're not just searching for answers, we're becoming part of the story ourselves, adding our own chapter to the infinite tapestry of cosmic history. the search for alien life isn't just a solo mission, it's a collective endeavor that spans across borders, disciplines, and even generations. Collaboration is the backbone of this cosmic quest, bringing together scientists, governments, and everyday citizens in a shared pursuit of discovery. After all, the universe doesn't belong to any one nation or group. It's a treasure trove of mysteries waiting to be unlocked by the combined efforts of humanity. And when we work together, the possibilities are as vast as the cosmos itself. One of the most powerful examples of collaboration in the search for extraterrestrial life is international space missions. Take the James Webb Space Telescope, a marvel of modern science that was built through the partnership of NASA, the European Space Agency, and the Canadian Space Agency. This telescope, designed to peer into the atmospheres of distant exoplanets, wouldn't have been possible without the expertise and resources of multiple nations. By pooling their knowledge and technology, these agencies have created a tool that's pushing the boundaries of what we know about the universe. It's a reminder that when we unite, we can achieve feats that would be impossible alone. But collaboration doesn't stop at the government or institutional level. Citizen science projects have become a vital part of the search for alien life, inviting people from all walks of life to contribute to scientific breakthroughs. Platforms like SETI at home and Zooniverse allow anyone with an internet connection to analyze data, identify patterns, or even help classify distant planets. These projects not only accelerate the pace of discovery, but also democratize science, making it accessible to anyone with curiosity and a willingness to learn. It's a beautiful example of how the search for extraterrestrial life can bring people together, turning ordinary individuals into cosmic explorers. Even within the scientific community, collaboration is key. The search for alien life requires expertise from a wide range of fields: astronomy, biology, chemistry, engineering, and more. By working together, researchers can tackle complex questions from multiple angles, combining their knowledge to uncover insights that might otherwise remain hidden. For instance, astrobiologists studying the potential for life on Mars collaborate with geologists to analyze rock samples, while physicists and engineers design the instruments needed to explore distant worlds. This interdisciplinary approach is essential for piecing together the puzzle of life beyond Earth. Governments, too, play a crucial role in fostering collaboration. International agreements and treaties, like the Outer Space Treaty, create a framework for peaceful cooperation in space exploration. These agreements ensure that the search for alien life is conducted responsibly, with a focus on shared goals rather than competition. They also pave the way for joint missions, like the upcoming Artemis program, which aims to return humans to the Moon and eventually send them to Mars. These ambitious projects rely on the collective efforts of nations around the world, proving that when we work together, there's no limit to what we can achieve. At its core, the search for alien life is about more than just science. It's about connection. It's a reminder that, despite our differences, we're all part of the same human family, united by our curiosity and our desire to understand the universe. Whether it's through international partnerships, citizen science, or interdisciplinary research, collaboration is the key to unlocking the secrets of the cosmos. And as we continue to explore, we're not just searching for aliens, we're building bridges between people, cultures, and ideas, creating a legacy of unity that transcends the stars. In the end, the greatest discovery might not be finding extraterrestrial life. It might be realizing the incredible things we can accomplish when we come together as one. Have you ever stopped to wonder why the universe seems so perfectly suited for life? From the precise balance of forces that allow stars to shine to the delicate conditions that make Earth habitable, it's as if the cosmos was designed with life in mind. This idea, known as the Anthropic Principle, suggests that the universe's physical constants and laws are fine-tuned in a way that makes life possible. But if the universe is so finely calibrated for life, does that mean we're meant to find alien civilizations? Could our search for extraterrestrial intelligence be more than just a scientific endeavor? Could it be part of a larger cosmic plan? The Anthropic Principle comes in two flavors, the weak and the strong. The weak version argues that we observe the universe as it is because, well, we're here to observe it. In other words, if the universe weren't fine-tuned for life, we wouldn't exist to ask these questions. It's a bit like winning the lottery and saying, "Of course I won, otherwise I wouldn't be holding this ticket." But the strong Anthropic Principle takes it a step further, suggesting that the universe must have properties that allow life to arise. This version raises profound questions about the nature of reality. Is the universe intentionally designed to produce life, or are we simply lucky to exist in a universe where the conditions are just right? This idea of fine-tuning has led some to speculate about the existence of a multiverse, a vast collection of universes, each with different physical constants and laws. In this scenario, our universe is just one of countless others, and it's no coincidence that we find ourselves in one where life can thrive. But even if the multiverse exists, it doesn't necessarily explain why our universe is so hospitable. Some scientists and philosophers argue that the fine-tuning of the cosmos points to something deeper, perhaps even a guiding intelligence or purpose. It's a thought that blurs the line between science and philosophy, inviting us to consider whether the search for alien life is more than just a quest for knowledge, it's a search for meaning. But what does all this have to do with aliens? If the universe is fine-tuned for life, it stands to reason that life might be more common than we think. The same conditions that allowed life to emerge on Earth could exist elsewhere, potentially giving rise to countless civilizations across the cosmos. And if that's the case, could our search for extraterrestrial intelligence be part of a larger cosmic narrative? Imagine a universe where life is not just a rare accident, but a fundamental feature, woven into the fabric of reality. In such a universe, the discovery of alien civilizations wouldn't just be a scientific breakthrough, it would be a fulfillment of the universe's purpose. Of course, not everyone agrees with this view. Skeptics argue that the fine-tuning of the universe could be an illusion, a product of our limited understanding of the cosmos. After all, we've only just begun to explore the vastness of space, and there's still so much we don't know. What seems like fine-tuning today might be explained by deeper laws of physics tomorrow. But even if the Anthropic Principle is just a temporary explanation, it still raises important questions about our place in the universe. Are we alone, or are we part of a grand cosmic story, one that includes other intelligent beings waiting to be discovered? The mystery of cosmic coincidences challenges us to think differently about the universe and our place within it. Whether you see the fine-tuning of the cosmos as evidence of design, luck, or something in between, it's clear that the search for alien life is more than just a scientific endeavor. It's a journey into the unknown, a quest to understand not just whether we're alone, but why we're here in the first place. And as we continue to explore the cosmos, we're not just searching for answers, we're uncovering the story of a universe that might have been waiting for us all along. Imagination is the spark that ignites the search for alien life. It's the force that drives scientists to peer into the unknown, dreamers to sketch visions of distant worlds, and storytellers to craft narratives that stretch the boundaries of what we believe is possible. Without imagination, the search for extraterrestrial intelligence would be a dry, mechanical process, a checklist of data points and calculations. But with it, the quest becomes a journey of wonder, a fusion of science and creativity that pushes us to explore not just the cosmos, but the limits of our own minds. Think about the role speculative fiction has played in shaping our understanding of alien life. From H.G. Wells' The War of the Worlds to Arthur C. Clarke's 2001, A Space Odyssey, these stories have inspired generations to look beyond Earth and imagine what might be out there. They've given us visions of alien civilizations, from the terrifying to the benevolent, and in doing so, they've prepared us to confront the possibilities of the unknown. Science fiction isn't just entertainment, it's a testing ground for ideas, a way to explore scenarios that challenge our assumptions and expand our thinking. But imagination isn't confined to the realms of fiction. It's also at the heart of groundbreaking scientific theories. Take, for example, the concept of wormholes, hypothetical tunnels through space-time that could allow for near-instantaneous travel across the universe. While the idea originated in the equations of general relativity, it was the imaginative leap of scientists like Kip Thorne that brought it into the realm of possibility. Similarly, the idea of Dyson spheres, megastructures built around stars to harness their energy, emerged from a blend of hard science and creative thinking. These concepts, once dismissed as speculative, are now taken seriously as potential avenues for discovery. Imagination also plays a crucial role in how we interpret the data we gather. When astronomers detect an unusual signal or an unexplained phenomenon, it's their ability to think creatively that allows them to consider a wide range of explanations, from natural processes to the handiwork of alien civilizations. The search for technosignatures, for instance, relies on imagining what advanced alien technology might look like and how it might manifest in the cosmos. Without this creative approach, we might miss the clues that lead to the most extraordinary discoveries. And then there's the way imagination shapes our perspective on the search itself. By envisioning a universe teeming with life, we open ourselves to the idea that we're not alone, that somewhere out there, other beings might be looking up at their own night skies and asking the same questions we are. This shift in perspective isn't just inspiring, it's transformative. It challenges us to think beyond our own planet, our own species, and our own time. It reminds us that the universe is a place of infinite possibilities, and that the answers we seek might be as strange and wonderful as we dare to imagine. At its core, the search for alien life is as much about exploring the frontiers of our own minds as it is about exploring the cosmos. Imagination fuels our curiosity, propels our science, and connects us to the larger story of the universe. It's the thread that weaves together the dreams of storytellers, the theories of scientists, and the hopes of dreamers. And as we continue to search, it's this imaginative spirit that will guide us, reminding us that the journey is just as important as the destination. After all, the universe doesn't just reveal its secrets to those who look, it reveals them to those who dare to imagine. The universe is a stage where civilizations rise, flourish, and inevitably fall. Whether they're bound by the limits of their own technology or the relentless forces of the cosmos, no civilization lasts forever. This brings us to a haunting question: what happens when alien civilizations die? Exploring the possible fates of these societies isn't just a matter of curiosity, It's a way to reflect on our own future and the challenges we might face in a vast, unpredictable universe. One of the most sobering possibilities is self-destruction. History has shown us that even the most advanced societies can collapse under the weight of their own innovations. Nuclear war, environmental devastation, or the misuse of artificial intelligence could all spell the end of a civilization, no matter how far they've come. Imagine a world where technology outpaces wisdom, where the tools meant to elevate a society instead bring about its downfall. It's a cautionary tale that resonates deeply, reminding us that progress must be balanced with responsibility. But self-destruction isn't the only threat. Cosmic disasters loom on a much larger scale. A nearby supernova, for instance, could bathe a planet in deadly radiation, wiping out life in an instant. Or consider the impact of a massive asteroid, like the one that ended the reign of the dinosaurs on Earth. These events are rare, but over billions of years, they become inevitable. Even more dramatic are the slow, inexorable processes of the universe itself. Stars eventually exhaust their fuel, expanding into red giants or collapsing into black holes, taking their planetary systems with them. For civilizations living in the shadow of such events, survival might be a race against time. Then there's the possibility of gradual decline. Over millennia, societies might succumb to stagnation, their once thriving cultures fading into obscurity. Resources could dwindle, populations decline, and the spark of innovation dim. In this scenario, civilizations don't collapse in a blaze of glory, they simply fade away, leaving behind ruins and relics as silent testaments to their existence. It's a quiet, almost poetic end, but one that raises profound questions about the sustainability of growth and the resilience of life. But what if some civilizations find a way to outlast these challenges? Could they escape the fate of extinction by transcending their physical forms? This is where the idea of post-biological life comes into play. Advanced civilizations might upload their consciousness into machines or virtual realities, becoming immortal in a sense. Others could evolve into entirely new forms of existence, merging with the fabric of the universe itself. These possibilities stretch the boundaries of imagination, suggesting that the end of a civilization might not be an ending at all, but a transformation into something unrecognizable. By studying these scenarios, we gain more than just insight into the fate of alien civilizations. We gain a mirror for our own. The challenges they face, whether technological, environmental, or cosmic, are not so different from the ones we confront today. Their stories remind us that survival in the universe requires more than just intelligence. It requires adaptability, foresight, and a willingness to confront the unknown. And as we look to the stars, searching for signs of life, we're also searching for clues about how to navigate our own uncertain future. The mystery of cosmic endings isn't just about the fall of civilizations, it's about the resilience of life itself. It's a reminder that even in the face of inevitable decline, there's always the possibility of renewal, transformation, and rebirth. Whether through the lessons of the past or the possibilities of the future, the stories of alien civilizations offer us a glimpse into the endless cycle of creation and destruction that defines the universe. And in that cycle, we find not just a warning, but also a source of hope, a testament to the enduring spirit of exploration and discovery that drives us ever forward. As we wrap up this captivating journey through 36 extraterrestrial enigmas, the search for alien civilizations, it's impossible not to feel a sense of awe at the sheer scale of the universe and the questions it holds. From the haunting silence of the Fermi Paradox to the tantalizing whispers of ancient alien ruins, each mystery we've explored has pushed the boundaries of what we know and what we dare to imagine. These enigmas aren't just scientific puzzles, they're invitations to dream bigger, to question deeper, and to see the cosmos not as a static backdrop, but as a living, evolving story. The beauty of this search lies not just in the answers we hope to find, but in the journey itself. Every radio signal analyzed, every distant exoplanet studied, and every strange celestial phenomenon observed brings us one step closer to understanding our place in the universe. It's a journey that transcends borders, disciplines, and generations, uniting us in a shared quest for knowledge. Whether you're a seasoned space enthusiast or someone just beginning to explore these ideas, the search for alien civilizations is a reminder that curiosity is one of humanity's greatest strengths. And while we may not yet have definitive proof of extraterrestrial life, the absence of answers doesn't diminish the importance of the search. In fact, it's the unanswered questions that keep us moving forward, driving innovation and inspiring new ways of thinking. Each discovery, no matter how small, adds another piece to the puzzle, bringing us closer to a moment that could change everything. So, as we close this chapter, let's not stop looking up. The stars above are more than just points of light, they're windows into a universe brimming with possibilities. Who knows what secrets lie hidden in the depths of space, waiting for someone like you to uncover them. Keep asking questions, keep exploring, and remember, the next great cosmic revelation could be just around the corner. If you've enjoyed this deep dive into the mysteries of the cosmos, don't forget to hit that like button, share with fellow space enthusiasts, and subscribe for more mind-bending explorations of the universe. Together, let's keep unraveling the enigmas that make the cosmos such an endlessly fascinating place. Until next time, keep your eyes on the stars and never stop wondering